Okay, so hello everyone. Let's start the second day of the first GambiConf European edition. So it's a new event. It's a first GambiConf edition. It's a new kind of a new event, and probably you are wondering about what you can expect about the GambiConf. What is purpose? So we have a lot of tech events. We have events like CodeBeam, that's a focused on language that runs on a Beam virtual machine. But hey, GambiConf isn't about a language or a specific environment. So GambiConf isn't like CodeBeam. We also have events like Go to Conference that's focused on technology, on forefront technology and the researches. But major part of the GambiConf talks don't aim to be necessary the latest researches or something useful to their workday. Of course, you have talks about something useful for your job, but it's a side effect because we like to do fun projects. We are developers that like to do pet projects. And the GambiConf has a simple and very simple goal. We just want to make computer fun. And the GambiConf is the place that you can share your achievements of the project that you did just for the sake of curiosity. And you can learn a lot by seeing the other personal projects and be inspired with new ideas. And by the way, it's important to have a pet project because a good way to explore new ideas that would be hard on your job and in the future maybe it can be useful. It's also possible to understand better the GambiConf by know how it came about. And BangBangCon is the major GambiConf inspiration. It's an event focused on things that can make you surprised about computer. And I founded this community by this very good talk, explain how to run a game inside of PDF file. And yes, it's possible to make a game run inside of PDF file, like this one. And by this very fun talk, you can be motivated to learn more about how is a PDF specification and try to extend its limits, like run other game or on other file formats or run more complex game instead of PDF file, like maybe it can run down. There are other talks in the same community, like this one, explain how is the tail optimization by a musical. It's a very fun talk. I was thinking more of the communities and I found this one, called Sigbovic, that focused on making a computational heresy like this one, explain how PowerPoint is Turing-Completeness. And by this very crazy talk, you can be motivated to learn more about the computer science topic like Turing-Completeness and the other related. And both Banco and Sinkbovic are very amazing events, but they had one issue. They are too far. Both are America events, but there are a lot of people live far from America or be hard to get a visa. And I am Brazilian, and I know that there are a lot of amazing people in Brazil who do fun project the same bug way, but it's missing a place to share this kind of talks. So let's start a new community, start a new event. That's the place that you can share this kind of different subjects. In the last year, you had the first GambiConf edition in Brazil with 2 days of very fun talks about second photo optimization, running down inside of oscilloscope, talk about game emulation, make computers just water, and so on. And I'm living in Portugal right now, and I noticed that the same issue that I had in Brazil, miss a place like GambiConf, also happening here in Portugal. And it decided to make the second edition here. And in the last Saturday, you have one fun day with a very good talks, a coffee break, and a good network. And also let's extend the event during an online day because it'd be great for people that want to talk and share some pet projects but can't come to Portugal. And they also spread the word about the GambiConf. Look to make computer fun. And in short, GambiConf is a tech agnostic conference. You can have it talk about any language, JS, Elixir, Rust, and so on, or hardware, low level, top level, and so on, because we are looking on what's unique on your subject, what someone can learn by a very crazy and unique idea, have mind blow and surprising moments. And we also want to motivate people to try new ideas for the simple sake of curiosity. Do it just because it's fun. So let's see the schedule for the online day. You have a talk about the reverse engineer on gaming. I have talk about a new browser. I have a talk with crazy rush optimization. I have a talk about doing gambiarras using Python. I have a talk about security. I have a talk about migration to GitLab. I have a talk about the routers. I have a talk about PHP. I will talk about the reverse engineered satellite communication. And at the end of the day, you have a talk about the Turing-Completeness. And to make it all possible, we have a couple of partners. I want to thank for Lisbon that was hosting the Inson Day. Also thanks to Href that sponsored one of the speakers. Very thank to Reactor that was sponsored the photography, coffee break, and one of the speakers. Thanks to Kubook that sponsor one of the speakers. Thanks for this podcast that was helping to spread the word. And if you want to push this idea to make computer fun, you can become a GambiConf partner. And follow us on the social media. I am more active on Twitter. I also have LinkedIn page, and we are. I'm Maccabeus, the guy who's organized this event. I work at Anima. I have open positions, and follow me on my GitHub, on my Twitter, Maccabeus and B Maccabeus. And I will be busy on the backstage, and we spend the major part of the time with Worms as master of ceremony. Thank you. Hello,
Hello, hello.
Worms.
How are you? Can I do you have any questions? Can I?
I'm good, and let's start.
Okay, I can start then. Hello, everyone. Thanks, Bruno, and thanks, Camilo, and everybody that is working at GambiConf for the invite to talk here and help them make the presentations glue with each other. So I'll be here while their like talks are not happening, and I'll be here to try to make like fish some questions from the chat and make them to the speakers afterwards. So when the talk is not a recording, the person will be live here with us, and feel free to chat and make questions. So we'll try to make them to the person when the talk ends if we have time. So the first question, the first talk, like Bruno showed, will be about Klonoa in Sonic 1 by Barak. I think, sorry if I pronounce the name wrong. I'll have to ask when the person comes here. Hello. Uh, oh, he said his mic is not working. It's fine. Try to fiddle with the settings on the page. And let me think if there's anything to say. Mm. Ah, I forgot to say something. Yes, I can say
Hey.
why.
Oh,
Hi,
okay. There you go. All
hi,
right.
Barack.
It does not. It did not recognize my mic by default for some reason. I don't
It's
know
fine.
why. Well, at least I got it over with. That was a bit embarrassing.
No, it's okay.
Oh,
Uh,
yeah, no, it's fine.
well, welcome then, and take the
Hmm.
stage and do your talk. I'll come afterwards to so we can speak a bit about your talk and see if we have questions from the audience.
All right. Yeah. Okay. So I'm Barack. I'm just basically you can tell from my character and my profile pic. I'm just basically a Sonic fan, and yeah, I sometimes do ROM hacking, which you know, um, yeah. So for those who don't know, Sonic fan base is a very expensive place with all sorts of different fans and a lot of creatives in it. Some of those creatives, what they do is that they take the original classic Sonic the Hedgehog games for Mega Drive that a lot of people know, and they basically, they modify them, turn them into either different things, add levels and whatnot. And this is a thing that has been evolved for many years now. I mean, people have been doing it for a while. In fact, there's an yearly event called the Sonic Hacking Contest that's been around since 2000. So yeah,
No, it's amazing. I love the, like modding and speedrunning communities. To be honest, I always look them up for the games I play.
yeah. So yeah,
But
I personally, uh, yeah, I basically started ROM hacking because
no, it's
so
fine.
people, yeah, no, it's not supposed to be not fun. What I'm saying is I started ROM hacking. I mean, some people do it for different reasons. Mine is for the simple reason I just like the classic Sonic games, and I thought the ROM hacking community looked cool because there's a lot of very insane stuff going on there. A lot of cool hacks. Um, I decided, I'm gonna try to do something with it. I remember one of the first hacks I made that was kind of inserting my friend's character into the game. I don't think I have the source for that anymore because it was pretty bad.
But it's so
I'm also
funny.
known, yeah,
When games come to PC, there's always these videos online where people change the main characters for another, and it's like
yeah.
it's
Well,
super.
this is not really PC. This is still a Mega Drive ROM. It's still a
Nah,
Mega Drive.
nice. Yeah. So you're
Yeah.
modding in the. You're gonna show us directly in the console.
I don't have my console connected to my capture card, so I'm not gonna be doing that.
Ah, okay.
Emulator is the best X thing, though. It's good enough. I don't need real hardware, honestly.
Wait.
I'm gonna be showing this for region. Um, yeah, my hack is basically when Klonoa Reverie series was announced. I was very excited because I know I'm a Sonic fan, but I'm absolutely a fucking Klonoa fan. You have no idea. And yeah, I was just kind of like I kind of miss ROM hacking because I haven't done it in a while. Like, why don't we just
I personally
let's
don't
try.
know Klonoa from the Sonic lore. I don't. I don't think it.
It doesn't work. I'll be honest. Now, my hack does not make sense, not from a mechanical standpoint, not from a story standpoint, but
Ah, okay.
it's fun to make for me, so I don't give a shit.
No, of course.
Okay.
It's fun. Well,
So how do I screen share?
yeah, you can. There's the button
Yeah,
besides the
there it
set.
is. Okay,
Or
give me a moment.
screen
I need
share.
to let me pull
And
it
what
up.
I forgot to say is that there is a person that is on the backstage. It's Tom, and Tom is helping us doing everything, like from putting your screen share here and taking me off. So thanks, Tom, and he'll be accompanying me when I
Thank-
say, "Hey, Tom, do
Thanks a
this."
lot, Tom. Keep it cool. Stay cool, bro. Anyways,
So
let me find my folder real quick.
thanks,
It
Tom, again for helping.
should be here. I should note, there is a crash bug in this. I'm still trying to figure that one out.
Live coding. It's gonna show up in live coding for sure.
Most likely it will happen. All right, tell me if you can see it.
Yeah, we can see it.
Okay. Yeah, I'm using Region. I think it's a good emulator for testing, not so much for casual play, but it'll do it for now. The title screen is still unchanged. Haven't done with that anything with that yet. I'm mostly focusing on mechanics. So I can see we have Klonoa here. I have the laugh counter as well. And yeah, he has his little idle animation from. Oh, yeah, I think something was wrong with the. They can see the idle works. I basically removed Sonic's momentum, which is kind of the whole point. But that's basically how Klonoa usually works. You can also do the flutter jump. You can, and of course, you have these trusty wind rings and wind bullets, and I can pick up enemies just like in Klonoa games. Of course, I can fire them in other objects and other enemies. I can do it here. Okay. The mouse is in the way. Hold up. Of course, just you can also use enemies for double jumps like this. That's cool. I just thought it'd be interested to see if I can do it, because I thought I wanted something to practice on, because I haven't used assembly in a while. Originally, I was not sure if I should make monitors destructible with the wind ring, because I wanted people to like destroy it by throwing other stuff at it, because that's what you do with like the eggs in Klonoa. But yeah, that's but I found that that was a bit too annoying to do, so I decided to keep that out. And yeah, I don't know what to do about this. I'm thinking of like maybe putting like maybe a flying enemy here, so instead you would just kind of do a jump over the loop with it. This does not work at the moment because of the way that acceleration and deceleration work in the game, and this I can easily remove this. I just didn't have the time. God, let me go down here. Yeah. See if I can at least beat Act 1. Oh yeah, I also added the front and back sprites, because why not? I'm walking towards the camera like in Dream Champ, but yeah. Also, I think this part fits this mechanics pretty well, because I can. Oh god. Yeah, this is what I meant. So far, my guess is what the problem is, that the game has a problem with collision. I did have to mess with how the game uses collision, and because there's more than one object relation here, because the game originally is like it's only Sonic versus the environment, but now there's other enemies that other things that the game has to calculate, like the enemy that I throw and the wind ring. So yeah, I think there's a problem with double collision. Like if one of two of these objects touch another object, like it will branch somewhere that it shouldn't. That usually causes an issue. Try showing. I kind of want to show what happens in Act 3, though. It can be pretty funny. While I'm playing, just want to point out that I do have other things that I worked on. People know me. I originally, oh, yeah, that's another thing I need to fix. Speed choose changed Klonoa's physics back to Sonic's, because it's just how that works. So now it controls like Sonic 1 for the most part. But I was gonna say, I'm also known for like making Sonic 1 Mania Edition, which is a hack that I made before Sonic Mania came out, because I wanted a Sonic Mania demo, and we never got that. So I try to replicate the footage from the what we got and put into Sonic 1, see if I could do it. Kind of worked. People seem to have really enjoyed that one back when it came out in 2016. So I'm glad about that. Oh wait, I have to show this off. I forgot. So this originally this wall can only be destructed by Sonic Spin Attack, which Klonoa does not have. So yeah, I actually did program it to work with this. Okay, it did not work very well there. But if you walk towards it, but yeah, you can break that wall. Oh, how far again? Okay. Other than that, I am also known for making it seems like a lot of the things that I make are usually things that I do for practice. Because what I did after that is that I decided to try and translate Sonic 1 into my native language, which is Hebrew, which is a language that nobody cares about unless you live here, this small country of Israel, and not much of an incentive to really translate to that language when not that many people speaking it anyways, compared to English or Spanish. Yeah. Oh, wait, I didn't know I can. Oh, I guess I can hit him with the wind ring. I didn't know that. Never tried that actually. I guess the same code branch is there. I could swear he has like his own routines. It'll be interesting if I can actually beat him properly. What I initially wanted to show was that if you destroy Eggman with like an enemy, which I accidentally threw instinctively earlier, like his object just gets deleted, but the level will not know that he's gone, so you're just kind of soft locked. Funny. Yeah, I don't know what else to show at this point because oh wait, yeah. So the caterpillar is over here. That's what happens when you pick him up. Originally, what happened is their body will just stay there. It has to do with how it's programmed. Yeah, I thought this was probably the best way to handle it. Also thought of an interesting idea of maybe make it that like if you catch a caterpillar, you basically can throw each part of its body as a separate shot, and so you have like 4 shots. Not really something that really happens in Klonoa, but I thought it'd be an interesting thing to do. I don't know how useful that would be. Other than that, yeah, this is what I got so far. I don't know how much I'll be able to keep adding to this because as of recently, I've been kind of busy with IRL stuff and also kind of lack of motivation as well. So I'm just kind of. So I don't know what's gonna happen. I do want to keep working on this eventually, though. Hopefully, I can find a motivation to work on this a little bit more before the contest, which I forgot to point out. So the Sonic hacking contest thing that I pointed out, it's still going, and I'm gonna submit this to the expo of the contest. So you'll be able to download it there if you're into that. You might check out the other hacks that they have there because they usually have a lot of interesting things there. For to be honest, in recent years, they've moved away a little bit from Sonic 1 ROM hacks and more so to 3D Sonic games hacks and mods. There's also the fact that we now have Sonic Origins and we have the decompilations of the mobile versions of Sonic 1, 2, and CD. And those are usually a lot easier to work with. And also, they're actually running on PC and have widescreen support and stuff like that. So a lot of people basically moving away from doing ROM hacks. I do it because I don't know. I just like seeing my stuff on my Mega Drive. It's funny. I think it's cool. And also, I'm more familiar with it.
Hey,
Yeah,
Barak,
I don't know what. Yeah.
I have some questions. Were you gonna finish, or can I ask some questions for you? How
I was actually about to say that you're free to ask questions now because I don't know what else to say.
Okay, so if anyone has any questions, feel free to use the chat to make them. And to Barak, we have some time left. Let's just check. Sorry. Yeah, we have like 10 minutes, 15 minutes into the next talk. We can make some questions.
15 minutes. I was not prepared for. I was not prepared for this.
No, it's fine. Like you don't need to go to the end. If we finish, I can stay alone here.
I guess I can show some things that I'm planning to fix.
I have a question though. Like, where did you make the mod? Like, so did you open the ROM and like did you open
No.
which
Okay,
ROM did
so
you use, for example?
I wanted to point this out. Here's the thing. I think you're giving me too much credit here. Let me explain. So, like I said, Sonic ROM hacking is a thing that has been going on for a long time, and as a result of that, people have developed more tools and easier ways to do it. I'm not doing that from scratch
Okay.
entirely. So we have so over the years we have complete disassemblies, well, mostly complete disassemblies of the original classic Sonic games. So we basically have the equivalent of this that is basically like the source code of the game. It's not like I went in there and changed the address specifically and whatnot, because that would have taken, nobody has the time to do that like that. This is the reason why hacks go as far as they do, because we basically have a source code. We have we have disassemblies, so we can just literally edit the code and add what we want. And there's tools that make it easier too. Like if you want to add graphics, you have Flex2, you have SunMapid, SunMapid. For to be honest, a lot of those tools are very old, and they can crash a lot. But if you get used to them, they can do the job. You can work around their jank. You can
No, but it's yeah, I can feel that there are probably many tools to help you, like
yeah.
to explore all the assemblers and things like that. Uh, there is a question from the audience. If you
Yeah.
have dealt with translating languages that goes from left to right, such as English, to ones that goes from right to left, he said
Are
Hebrew
you?
as an example, and
Oh,
probably in context, like
if you look up my hack on YouTube, you'll see exactly what I did about that. And honestly, I guess it worked. Right there, basically, I literally just moved the UI to the right side of the screen.
okay, so you made
Because
like align right instead of align
yeah,
left.
because that's what, like, if you look at my Windows computer right now, a lot of programs that are in Hebrew, that's what they do. They just kind of flip the UI. Every time I screenshot my whole screen, everybody just lose their shit because they're just like, why is your taskbar on the, why is your start button on the right side of the screen? It's disorienting. And I'm just like, this is how I grew up with it. I don't care. You're the weird one. Why is your Windows button like on the left
It's good.
side?
It's just like driving. Yeah, the countries where
Yeah, no,
driving.
it's like driving in Europe versus anywhere else.
No, it's fun. It was a good question. Yeah, it's nice to know that it's easy and it's just on a line. You don't have to go through many internationalization issues.
Mm-hmm.
And so
It took a lot of work.
for the Klonoa you use, for example, you use the tool and you upload all the animations that you picked up from the other game. And did you have to
No,
fix anything by hand or it just worked? Like
I
for
did.
example, you said it's crashing now. So how do you fix the crash if you don't have the low level access?
Um, I have a theory of what causes the crash. It definitely has to do with the collision code. I'll just have to keep looking at it and experiment and see if I can recreate it more, so I can look at the subroutines that are related to it, and hopefully I can do it. I've actually already got a little bit of a lead for it, because I want to give a little bit of credit. So there's a very cool ROM hacker in the community. Known as Marky Jester. He made a lot of cool hacks, and I know him from a few, and I occasionally keep in contact with him. He actually helped me a bit with things that I was stuck on. I had other issues that he helped me with, and he's the one that actually told me this. He's actually a lot more experienced than I am. A lot of people in the community actually a lot more experienced than I am, believe it or not.
No, but it's
But
nice.
yeah,
It's nice that you're exploring this and adding the things that you like to the game because I imagine there are tons of other characters being added. Do you put this ROM somewhere, like a repository where everybody's putting their ROM so other people can play or something like that?
I explained this earlier. I'm gonna be
Oh,
putting
sorry.
this up on the Sonic Hacking Contest.
Ah, okay.
So it's gonna be in October. But
Wait. Until then, it's not publicly available then for anyone to play.
I mean, I did upload it to some people on Discord. Yeah, if you want, I can give you the current build. I don't care.
It's fun. I'd play just to see it here. But yeah, thanks. And if do you have anyone else you want to add? Something you want to close?
Yeah, I was gonna. Oh, wait, no, I already talked about marking. Yeah, never mind.
You can talk again
Sure.
if you want. If you do have anyone, any.
No, I don't. No, it's fine. I don't want. Oh yeah, another reason that Marky's helped me a lot is because he actually made really good, probably the best Assembly 68K tutorials out there. If you look up tutorials in Assembly 68K, which is the main language of the Mega Drive CPU, he has a really nice step-by-step tutorial that explains every command and he explained it like to the point. And I don't know any other programming tutorial that is as simple and as helpful as that one has been to me. Put the link even and it's not even like that like complete too. There's some things that he's not talking about, but like he talks about like the main things. He still talks about a lot of the basic things, and it's really good.
I was gonna tell you to put the link to his channel in the chat if you want, so people can check later.
Not channel. Nah, it's fine.
It's not a channel. Okay, sorry.
I mean, he does have a YouTube channel.
No, but, I mean to the guides, because you mentioned and said they were good, so people can explore later.
To be honest, I'm a little skeptic about this because I know how he would feel about me talking about it because without him knowing about it, that's the thing. But okay, fine. I'll put his channel. Sure, why not? He'll get a surge. He will never know. Oh yeah, actually, you should check out his recent video. He's been making this little series called The Hacker, which is it's basically a podcast where he interviews a bunch of people from the Sonic hacking community, a lot of old people from the community, and they have a lot of very interesting things to say from their experience. It's a really fun podcast. So, oh wait, hold up. Where is the thing? Okay, so where do I put the link? Do I just because I don't have access to like the? Do I just go to the private chat?
Yeah, you can put in the private chat.
Yeah, okay.
Somebody from the org put it on the chat first.
Well, I put his thing there. His channel also has a lot of videos about his work, which is really cool. He has a lot of wacky stuff there.
Thank you, then Barak, and thanks for the talk. It was nice to see your mod.
No problem. It's cool that you're doing this kind of event and thinking about those people that can't arrive everywhere. I think what you're doing is really nice. I hope you could get this to really work out.
Yes.
Yeah, I had fun enjoying my stuff.
Yes, it was very nice to see, and like it's very cool to explore these tools. Like I've also learned a lot, for example, on the game design side by exploring these weird angles on games. I highly recommend people to do it if they like games.
Oh, absolutely. It makes you appreciate things. It makes you appreciate things you didn't like, and also make you dislike things you used to love simultaneously. It's a new perspective and a new world.
Yeah. Thanks, Dan Barak. I think
All right. Thank you.
See ya.
So okay, have a good day.
Thanks. So Tom is gonna now change, I think, and remove Barak and
yeah.
Pierre is the next presentation. Let me wait a second.
So can I not disconnect manually?
Yeah, I think he managed to disconnect manually. I hope. Well, then we have Pierre, which is in the room here, and he's gonna talk about. I think it's Nyxt. I hope I pronounce Pierre and Nyxt right. He corrects me if I did wrong.
Yes. Hello. Can you hear me?
Yes.
Yes. All right. Yeah, my mic is not so good, so sorry about the noise. Hope it'll be fine.
No, it's fine. You can hear just fine.
Okay, good. So, hey guys, yeah, I'm Pierre Neithart from Atlas Engineer, and today I will present the Nyxt browser. It's a web browser that's a bit different. Let me share my screen now.
Okay, thanks.
Entire
Tom, I think you
screen.
can end the string and remove me already. And I'm gonna come back.
Okay, can you see my screen? Is there any message? Yes, okay, thank you guys. All right, so Nyxt browser. Yes, so like many open source projects, it came out of the frustration with the current browsers. On the one hand, we have the popular browsers like Chrome or Firefox, and I don't find them very interesting. I think like if you're a programmer, if you're a tech user, you like to customize your things. You like to add key bindings to this feature or that feature, and it's the kind of things that you typically cannot do very well with a program like Chrome. Yes, you have some extensions, but they're a bit limited, and the user interface is yeah, very inflexible. So on the other hand, we also have a bunch of like geeky browsers, like for the tech users. Like there's a legion of them, literally, and many of them are very interesting. But I find that in practice they don't really stand the test of time. Um, Maybe you've heard of the browser called Conqueror, which got deprecated when Firefox moved away from Zool XUL, the former extension language. And this happens a lot because typically these browsers are closely tied to the renderer, and that makes them very dependable. So we tried to make a browser that would not suffer from this issue by making it a bit more universal. And another aspect is extensibility. So many of these browsers, the geeky browsers, they focus on like some sort of extensibility, but I always find it a bit too limited to my taste. I mean, I really like to push the concept of extensibility to a whole new level. And well, this is what we try to do. And so today I will demo some of these extensibility features. And we, yeah, because the Nyxt browser really prides itself at creating something a bit new here, something more extensible than most programs. A little bit like the Emacs of the web browsers, if you heard of the infinitely extensible Emacs text editor. So for this, we've used a programming language called Lisp, very much like Emacs. The benefit of this programming language is that it allows for extremely good live and interactive programming, and I will demo some of this today. So let's get started. So I've recorded a quick video because I thought it would make the demo a bit smoother. So let me play it. Okay, so this is the entry point. So we see the main page here, and at the bottom, I run. So this is the entry point to the entire UX of the interface. It's essentially the power bar. We call it the prompt, and here there's a prompt that lists all the commands that are available. Now, what's interesting is that this prompt allows you for fuzzy searching. So uh, in this case, you see a bunch of commands that are suggested here. And if I start typing like URL set, it will match the set URL command, regardless of the word order, right? It's a bit smart about it. You can even complete against the bindings or the doc string that appears to the right. So that's the documentation, right? So if I type complete, then it will automatically narrow down to the only suggestion and so on. So let me create a new buffer. Yeah, so the first thing, what do we call a buffer here? It's essentially what we call a tab in other browsers. The reason we do not call them tabs is because we don't display them as tabs, because we find this UX element a bit useless when you have too many tabs. I mean, that's like the most typical problem with Chrome or Firefox, that when you get a crazy list of tabs, I mean, you get lost in them. And Sometimes you can search them. It's not super convenient, but then it's always a bit limiting. And I will show more of it later. So here I query wiki tomato to open a page on Wikipedia about tomatoes, right? So I can try to do this another time with the Lisp programming language, and we will open another tab or buffer about the Lisp programming language. So now I bring up a buffer of a prompt that lists all the buffers or tabs that I have opened, and it's three of them: the starting page and the two Wikipedia pages. And what's interesting here is that I can fuzzy search the tabs by their URL or by the title. Uh, and after doing so, I can even wait. Let me. Yes. So also notice that how the display of the prompt is structured, right? So we can display anything and with the properties like the title, the ID, and so on. We'll come back to this later. And okay, so now I can here I can narrow down to all the wiki pages and decide to select them all, and which automatically discards the non-matching pages, and then I can decide to run any action on top of it. So here I have a bunch of action in a recursive prompter, and I can actually create new actions. So anything I want, for instance, bookmark this buffer or persist them to disk, anything like this. So in that sense, it's much more powerful than the kind of tab search you can do in Firefox or Chrome, because well, you don't just search the buffer; you can actually act upon it. So, for instance, you can delete all the Wikipedia buffers in that sense. But let's not do this right now. So, yeah, let's get back to our Wikipedia page. And okay, let's consider this another example that I find pretty cool about Nyxt that I don't find in many other browsers. Is that you see the table of content here? It's on Wikipedia, but you see it in most pages. There's always HTML headers like H1, H2, H3, etc. And it would be nice to navigate them because they give structure to your page, and usually it's kind of a good mnemonic to know where you are on the page. So here we implemented a prompter called jump to heading, which automatically lists all the all the headings. And as usual, as with any prompt, you can actually first search the heading. For instance, here we go to the major dialect, and it will automatically get us on the page, like scroll down to the appropriate section. And as we navigate the header, then it gets us to the section. So this is a very general concept. And now let me come back to this presentation in a prompter where we display URL, title, ID, etc. So we can display, because it's programmable, you can also display whatever you want about these suggestions that we're displaying. So here we have URL and title, which makes a lot of sense for a tab, but there's also the ID and so keywords. Now, let's say I'm not interested in displaying the ID. Well, I can actually unselect idea like here, and now it's gone. So it actually it updates the prompt live. You can add more elements, you can remove them, etc. Okay, so okay, let me go to our front page. Nyxt as an engineer, visit the page, is quite interesting, has some cool examples and articles. Now, another feature that's very popular in many of the geek browsers, there's also a bunch of extensions for Firefox. I think it's Vim or these kind of things. Is the ability to navigate links with the keyboard. And these are typically called hints or link hints. Basically, you press a key and it displays this bunch of tags on top of all the links you can follow. And then if you press AA, it will automatically follow the link that corresponds to the hint. Now, in most browsers, it's a bit what's a bit inconvenient is that you got to read the link hint, for instance, AA, AB, AC, etc. But what if you want to click on download, and but you don't know that it's going to be AN in advance. So if you type, let, let me wait for the demo. Okay, so if you type AN, it will automatically narrow down to the download. But you can also type down, and it will narrow down to the download page as well. So you can actually first search not only by hint, by the letters, but also by URL, or even by the text of the corresponding to the URL, and so on. So that gives that basically paves way for very powerful type of keyboard manipulation of your web content. Okay, so let's move on to a different topic, that of history. So in most browsers, the history is something linear. So you have the forward button, the backward button, and the thing is that it doesn't really represent what you navigated. So let me give you an example. I go to the programming languages page in Wikipedia. Then I go back, I click on another link like Alonso Church, sorry. Then another link, lambda calculus, okay, all the geeky mathematical things. Okay, now I go back twice to my original starting page. Now, if you've been following what I've been doing, at this point, you'll notice that I've been branching. So the history is not branching. It means that we have technically two forward children in history. The first page we visited, which is programming languages, and the second, which is that of Alonso Church. But in a regular browser, if you click forward, it will only bring you back to the last page you visited, which is Alonso Church. So the forward history of the contained programming language is gone. So if you lost information there, I think that's a pity. I mean, in general, like if you stick to the same tab and you navigate for many URLs, well, chances are that you will erase much of the history that you've navigated. So in Nyxt, we don't do this. Instead, we store the history as a tree, which means that we always keep information of everything we've ever visited. So let me display this concretely, actually in form of a tree. So we have a command for this, which is called buffer history tree. And there. So it's exactly it exactly represents the navigation, right? So the first link is the one we started from, the Wikipedia page about Lisp. Then we navigated to programming language, went back, and then navigated to Alonso Church. Finally, to the subpage from there, lambda calculus. And then we went 2 parents up, back to Lisp programming language, which is in italic here, so it's the current page. Now, all these links are clickable, so it allows me to navigate back to history, where I was. So I hope this is clear. Maybe it's a bit confusing at first, but it's a very powerful thing. And all these history navigation things are available as comments as well. History forwards, backwards, and all the entries also fuzzy searchable. Cool, right? So yeah, that gives you a lot of power. I mean, you don't need to click, and so on until you find the right page. Now, we talked about history. Let's talk about bookmarks. So let's bookmark the current URL. So what is a bookmark? A bookmark is basically a URL, usually associated with the title, but we can add extra data. And in Nyxt, we made sure to add as much data as we could. So one thing we do is that we have a text analytical engine, which essentially parses the page and tries to collect the most meaningful keywords. So here it appropriately got at least 2 good keywords here, Lisp and language. So I will select these 2 and it will add them to the bookmarks. And these will be used as tags. So you can do this in Firefox as well. I mean, bookmarks can have tags, and then you can filter all your bookmarks by tags. So it makes for convenient and composable grouping. Now, let me show where these bookmarks are stored. So they are stored in a file, and I can actually access this file directly from Nyxt. I can call the command edit user file, which lists all the files that are editable from Nyxt. There, so that's my bookmark file, and it opens it in Emacs, my favorite editor. Well, it opens it in any editor, right? So that's the list of my 3 bookmarks. So 1 line per bookmark. You see here there are the tags that I've selected. There's the date, the title, and the URL. And what's convenient is that there is one bookmark per line. It's stored in a human readable fashion as well, so you can edit it by hand. And it also means that you can keep it under version control, like with Git, and you can store your bookmarks on GitHub maybe or whatever. And it's friendly for the version control because I can show the diff and the history in a meaningful fashion. Okay, so much for bookmarks. Now let's talk about something else, something that's very dear to the heart of all the geeks out there: the key bindings. Geeks really like to have to customize the key bindings to their favorite flavor, like VI bindings or maybe um, Emacs bindings. So here I will enable some. So the thing with the thing with Nyxt is that it comes with three different flavors out of the box. The CUA flavor, which is Control C, Control V, etc. The regular, more familiar kind of key bindings. But it also comes with Emacs, the Emacs flavor, and the VI flavor for Vim users. So here I will enable a mode, Emacs, which enables the Emacs key bindings. So now you see that, sorry, to the bottom right of the screen, Emacs is displayed, which means that the Emacs mode is activated. Now I can press Control N and Control P, which is like the regular bindings for Emacs to scroll up and down. Here I've enabled the VI normal bindings, so now I can press G and K, and if I click on a text box, you notice that the N has switched to I for insert mode. So if you're familiar with Vim, you know what it means. It means that now I can press J and K and will appropriately insert the characters instead of scrolling up and down. If I press Escape, I go back to normal mode, and now I can disable the mode and go back to the CUA bindings. So what's remarkable about this is that so modes in Nyxt are very much like extensions in Firefox or Chrome, but the main difference is that they are not global. They actually work per tab. And that's very interesting because it means that you can enable Emacs bindings in one tab and CUA bindings in another tab. But let me give you a better example for a good use case of this. Like it's more general than globality. It's actually locality gives you more general control over what you can do with your browser. So let me go to the Tor browser page, which so if you download Tor, it's essentially an enemy privacy enforcing how to say well, it works as a proxy here on my computer. I've installed a proxy, and it will detect, this web page will detect if I'm going through Tor or not. So here it tells me that I'm not using Tor because I'm using the default settings. However, if I enable the proxy mode, which is configured to use the Tor proxy, then so I enable the mode, press enter, it displays to the bottom right. Now I can reload the page, and the web page tells me it's configured to use Tor. But what's interesting is that if I go to this other page, well, or this the tomato page on Wikipedia, new page, it won't be using a proxy, so it will still be using the regular connection. So this allows me to separate tabs using a proxy from tabs not using a proxy. This is super convenient, and for some reason, it's kind of hard to do in other browsers. Same like here, I can disable JavaScript. So if I reload the page, you will see that the link here disappears. JavaScript is not disabled, but it's still enabled on the Wikipedia. So if I try to search here, you will see that the JavaScript is still working. Okay, so that's yeah, I've been demoing so far a lot of features. Now, what about the programmability aspect of Nyxt? So like I mentioned before, it's written in Lisp, and we have an integrated Lisp REPL. So a REPL is essentially a command prompt, like you would have for Python, for Ruby, any programming language that's a bit interactive will usually feature a REPL. So this is a regular some Lisp REPL, so we can write any code. So here a simple addition. All right, so far so good. Now let's say that I write a typo. So I want to compute an exponential, but yeah, I wrote it wrong. So if I press enter here, it will, oh, okay. So it will tell me that there's an error and display the debugger. and I can actually interact with it from the browser itself. Now, I can compute the exponential properly, and you see that it handles big numbers perfectly well. That's regular Lisp. Now, what if we do something that's a bit more related to Nyxt itself, to the browser? So the current buffer function returns, well, the current buffer or tab object, if you will. And notice that it's a link, so I can actually click on it. What happens? Let's see. All right, so it brings me to a new page, which is essentially an inspector of the object. And it lists all the different attributes of this object, which are modifiable with the change button. But I can also see how it also displays some other links. And that's because the inspector is recursive. So I can click on one of these links. Let's see, maybe this one. Yes. Okay. Sorry. Let's click on the URL. Okay. Now I inspect the URL, and I have all the URL attributes there displayed as well. So yeah, it makes for a very powerful introspection of all the core of Nyxt. So not just the extension, not just the surface, but really everything is accessible from there. But not just from within Nyxt. We also enable remote programming, so you can use your favorite editor, your favorite IDE to program Nyxt while it's running. And this is key. I mean, we're talking about live programming of the browser. So here I can run the command start slang or swank, which is basically a language server. So if I execute it, then I can switch to my repo. So this is Emacs running Sly. Well, it's environment development for Lisp. It's a pretty good one. You can choose the one you like. And from here, well, I can basically do the exact same thing. I can call the command current buffer. And from there, it gets me also an introspectable item. And I have a different interface to introspect and program everything. So I won't go more into details because then it becomes like some hardcore Lisp programming. But from there, you can create commands, bindings, shortcuts, pretty much everything. So that's it for the demo. I hope you liked it. Thank you for watching. And well, I'll stick around for some questions. Allow me to unshare. Oops.
Very nice. I have some questions. I don't know. The audience still haven't sent some, but I have some.
Yes.
Well, the first I have one about plugins. How is the plugin ecosystem? For example, I depend a lot on some plugins on Chrome.
Yes. So that's a popular question, and that's a tough one. So there are basically two categories of plugins, you could say. One is a Lisp extension. So because I mean, out of the box, basically the programming language gives us support for Lisp extensions out of the box. So anyone can write their own extension using Lisp, and just like in Emacs, you would write an extension as well. And you can manipulate the whole browser. And these extensions are very powerful because they have access to the whole thing. So if we didn't expose something in our API, it's fine. The extension can still access the internals if they want to. There's some protocol for this. It's not like something insecure or anything. It's fine. But now, what about existing Chrome extensions? So these extensions, I mean, Chrome or Firefox, they're usually similar. So these extensions, they follow protocol standards, called web extension. That's the name of the standards, like AdBlock and this kind of things. And to support the standards is actually really tricky. We've been working on it for about a year. We've put it on hold. We've got some demo working, so we've made some great progress, and basically the base of the protocol is working, but we don't have we're not done yet. So something like uBlock doesn't work yet. We would really like to find the time to finish it because it's a feature that's extremely
This feature would make Chrome plugins and Firefox plugins compatible with it.
Exactly. Yeah. So it means that for the better part of it, plugins would be compatible.
Nice. And
yeah.
So like, I imagine you do developing or some kind of browse developing. Do you use any tool that you think like, oh, this tool doesn't have in Chrome and it's so handy here too? code? Like, what would you recommend for coders to try out?
Sorry, I'm not sure I got a question. What do you mean for coding?
Yeah, I was asking if you have, like useful, for example, there's a developer extensions at Chrome. You showed some, for example, the introspection element and things like that. Is there any other thing you would recommend developers to explore at Nyxt?
In Next.
Yeah.
Yeah. So that's that's an area we've been exploring as well. So we have a DOM, document object model API, so we can actually. Okay, so this is a little bit of a tricky question because it's quite technical, but essentially we have APIs to manipulate the DOM and then to manipulate JavaScript as well in ways that are not so easy to do with other browsers. So in that sense, Nyxt can give you some very powerful tools here. Very
Like
good
you
for
said, doing tabs with different proxies, for example. That's something I wouldn't be able to do at Chrome easily.
that kind of things, that's for sure, but that's more like on the UX side. But if you are talking about like web programming, we can also do things like manipulate the DOM using the power of Lisp in a way, and that means that you get very powerful tools. Like you get macros, you get introspection, you get these kind of things.
Yes.
That's really cool, and it's also live. And being live, that means that you don't have to restart your website. You can program everything within the browser. You just refresh and it works. That's pretty cool. But there's more that we'd like to explore. Like maybe you're familiar with a tool called Selenium, which allows for
Yeah,
like,
I know. Selenium.
so to essentially tinker with the content of the website. So there is a lot of room for improvement for Next in that area. So we've started doing some things there, but yeah, eventually we'd like to reach a bit closer to Selenium. That would be nice.
Okay. Well, thanks a lot, Pierre. It was great to see. I even joked it's kind of like Vim as a browser, and I love Vim, so it's very cool.
Yeah, exactly. It's very close to this kind of programs, for tech users. Like you can really hack it. You can fiddle with it, adapt it to your needs, these kind of things.
Well, thank you, Dan.
You're welcome.
And well, we have the next person, Tom. I think you can. I will try to pronounce. I think it's Z, but I'll wait for. Hello.
Hi. You got it right.
Nice. Nice that I got it right. Hello.
Yeah,
Z.
it's Z as in how Americans pronounce the 26th letter of the alphabet.
Okay. Very cool. So Z. Okay. So should I talk about he or she with you? Should I call you he or she?
Probably they. Just use she.
Okay. So they're gonna talk about dynamic web apps, and it's gonna be fun because they're gonna talk about over-engineering websites with Rust, and I'm super excited to see what this is about because I like over-engineering and websites. So please take the stage, and I'll come back later to see if we have questions from the audience and myself. Thank you. So I think Tom.
Speed, safety, development experience, fearless concurrency. These are all things that you associate with programs written in Rust. How about some more buzzwords? Words like elegant. Oh, that's a good one. I'm ZISO, and I'm going to share the gory details of how my blog works and why people often mistake it for a static website. Buckle up and kick back, we're going to learn about the internet today. I'm ZISO. You've probably seen my blog on that orange website or that other orange website. I also study philosophy and have been writing a novel. I work at Tailscale as the Archmage of Infrastructure, and I do developer relations. My blog is somehow one of the best resources for learning Nyxt and NixOS. This talk will contain opinions about website design and the like. These opinions are my own and are not the opinions of my employer. Websites are social constructs. There are only servers that speak this weird HTTP protocol and then sometimes spit out a markup language called HTML if you're lucky. This HTML is then understood by very principal humans or web browsers, and then it all gets transformed into roughly what the writer or designer wants it to look like. I write all my posts for the blog in Markdown in Emacs. Sometimes I do brain dumping or initial drafting in Apple Notes on my MacBook or iPad, but it all gets into Emacs eventually for publication. This Markdown has some front matter in YAML. This has metadata like tags, the series it is in, stream recordings related to posts, and when it is scheduled to be posted publicly. This is all used by the templates to make sure that I can't forget to put it in articles. But the main focus is on the contents of the post, the words I type out. In the process, I've organically grown my own custom Markdown dialect on top of a Markdown parser named Comrack. Comrack is made by a friend, and it is the most important part of this website. However, over the years, I've found that vanilla Markdown just isn't good enough for my needs. I've grown features out on my blog that require more fancy things like the conversation snippets and the newly added AI-generated hero images. At first, I just implemented a hacky Markdown extension. It applied the conversation snippet logic to anything that matches a Markdown link with a weird URL scheme. Unfortunately, that ended up not scaling well as the conversation snippets got more complicated, like when I need to add links. So I brought in a library called lol_html. I use this to transform my custom HTML elements into a bunch of other HTML using a bank of templates. This allows me to write Markdown with occasional HTML for the things Markdown can't express. Then I can rely on my blog engine to translate those shortcodes to what people see on the site. In my blog, I use a templating engine called Ruct that takes a weird meta syntax on top of HTML and then spits out Rust code. This means that when you load a page like my homepage, you're hitting a function that renders that homepage to a string buffer. That string buffer is what my website throws back into the void, and hopefully it all comes back to you on your end. As a side effect of doing all this, it happens fast. Really fast. So fast that it's faster than a static website. Turns out serving things out of RAM is very fast. And when I say fast, I mean that I have tried so hard to find some static file server that could beat what my site does. I tried really hard. I compared my site to Nginx, OpenResty, Tengen, Apache, Go Standard Library, Warp in Rust, Axum in Rust, and finally a Go Standard Library HTTP server that had the site data compiled into RAM. None of them were faster, save the precompiled Go binary, which was like 200 megabytes and not viable for my needs. It was a hilarious benchmarking session. I have accidentally created something that is so efficient that it is hard to express how fast it is. This is efficient and fast, but the syntax of Ruct is awful. I have to specify the types of my code in the template itself. I have to be sure that the automatically generated template code is importing any of the non-default traits I need. It works, but it kind of sucks. So I've been playing with Mod instead. Mod is a procedural macro library that lets you transform its own domain-specific language into HTML at compile time. You can make your components normal Rust functions. I use Mod for all of my shortcodes, and I've been slowly converting my site over to use it. It's pretty great. You should check it out. One of the biggest things you see me use these for is the little conversation snippets that I have in blog posts. This was originally created to absolutely dunk on homophobes that were angry that someone put furry art in an information security blog post, but this also lets me experiment with a more Socratic dialogue style for helping to explain things in more detail. I now write everything with this style and have to go back and edit it out for the work blog. My coworkers can confirm this. This flexibility also lets me add things like hero images generated with AI. I use these to help make my posts more visually interesting. I'm still refining my style and trying to make things better, but I'm just absolutely terrible at CSS. One of my favorite parts of how this site works is something that will probably make the theoretical computer scientists in the crowd start crying. When my blog loads everything from the disk into RAM, it stores all the posts in the moral equivalent of a linked list. When you, as a reader, look at one of my posts, it's doing a big O of N lookup on potentially every one of my posts to figure out which post to display. Normally, this would be terrifying, especially with the amount of traffic my blog gets, as represented by this handy graph here. You'd think that something that does a lookup on potentially every post in the worst case for the most common thing on the biggest dataset would make performance terrifyingly slow. You'd also think that with the amount of traffic that I get, it would be an active detriment and I'd be trying to remove it. However, this is when I play my trap card. When you look at the analytics, you can see that the most frequently read article is the most recently posted one. This means that it's not actually a big O of N lookup most of the time. It's constant time complexity. In theory, this design is the terrifying type of thing that you normally find out after you accepted a job offer and had your first day of work, but in practice it's fine. It is a bit weird though, and I may need to rethink this in the future, but this is scaled to almost 300 posts for now, so I think it's okay. When my site starts up, it reads every post from the disk into RAM. Rust makes that really easy. With Tokio, I can schedule a bunch of jobs and then wait for them all to finish. This lets me spread the load out to every CPU core so that the posts can load up to 12 times as fast as they would if everything was done iteratively. Once it's done loading them, it sorts them and then puts them into the list for the blog's data structures. I can do this in one line of Rust and it would be something like 50 lines of Go. Rust allows me to have a lower cognitive complexity because I can just rely on things being taken care of for me instead of having to reinvent the wheel all the time. I think in high-level logic and let the compiler take care of the lower-level details of making it work. It's great. An amusing part of all of this loading things into RAM stuff means that my website is actually stateless. This allows me to move it around to any server I want very easily in case something very bad happens. I can also take all this data in RAM and then transform it into whatever kind of feed I want. I currently support RSS, Atom, and JSON feeds so that you can subscribe to my blog with whatever reader you normally use. JSON feed allows for custom extensions, and I have played with one that gives you some of the extra metadata in my front matter that isn't exposed in JSON feed itself. Normally, this doesn't show much of anything useful. It's where I put things like the Twitch and YouTube links associated with a post, the link to the slides and talk pages, or the name of the blog post series if one exists. I don't know if anyone uses these, but I've been starting to use them for some of my internal pipeline things. I mentioned my website was stateless, right? Turns out that's not totally the case. It's mostly stateless, sure, but it also has a stateful component that organically grew to meet my needs. This stateful component sort of started out as a personal API for other things. I named it me after the Tokipona word for me. I use this daily to track some personal things, but it became really useful once I found the indie web concept of Posse. Publish on your site. Syndicate elsewhere. This concept allows me to post things on my blog and then have something else take over to announce those posts on Twitter and Mastodon with messages like this. Everything is automated. I don't have to lift a finger. Except for Patreon. Patreon's API doesn't allow you to generate posts, and sometimes I can forget to link the post to my patrons. I'm trying to get better about this, but I would really love to just hand this over to a machine and stop having to care about it. The other major thing I use this for is web mentions. Web mentions are kind of like app mentions or Twitter, but it's generalized for any website on the internet. It's another indie web protocol that a surprising number of websites support, along with bridges for things like Twitter and Mastodon. Me receives and stores all of the web mentions I get. When my site starts up, it reaches out to me and gets a list of web mentions for every post it loads into memory. This means that there's potentially some delay from you sending the web mention to it showing up on my blog, but in practice that's okay. I would like it to be faster, but that would mean having to move the web mentions database into my main blog app, and I don't know if I'm ready to do that or not, because it would make moving my website around a lot more complicated. So, I mentioned on my blog before that I host everything on one big NixOS server now. This means that I would be able to store things on that server fairly durably, but I also have mentioned that my site is stateless and it farms out its state to a stateful microservice. You may be wondering something like, why would you do that to yourself? I have a good reason for it, but in order to explain why, I want to take a moment to trace over the history of my website's hosting. Heroku's free tier was one of the things I used to break into tech. When I started my job in Mountain View and got my former domain name, I was likely using Heroku to host that website. I don't have notes from back then. I'm going off of my gut feeling and some projects that I have on GitHub. At that point, my website was a showcase of my ability to write things using a web framework called Lapis. You can think of it as Rails for Lua built into the side of Nginx. This variant of my website was in use for a few years until I rewrote it in late 2016. A huge part of how that website worked was that it parsed the markdown for each post every time the page loaded. This let me edit and test things very quickly, which made writing posts and previewing them in real time possible. I didn't fix this before my first article got to the front page of Hacker News, which meant that my website was a bit slow, but it did survive the load. Barely. After that, I set up a cache server named OlegDB. OlegDB is a key value store written in C by some friends, and it is a joke about mayonnaise that has been taken way too far. I used OlegDB in my website to cache the rendered HTML for each markdown post. When you loaded a page, it made another request to the OlegDB server to grab the contents from the cache. This was faster than parsing the markdown on every page load, and it ended up being the thing that made my site survive the wrath of Hacker News. Some time after my site was deployed on Heroku, I moved it over to a server running Doku. Doku is a self-hostable Heroku clone that lets you run a Heroku-like environment with Docker on a server you own and operate. I've used Doku for years since, and for a very long time it was the first thing I reached to when trying to deploy anything to the cloud. It's got templates for spinning up basically any database you could think of at the time, and it was trivial to just spin up infra when I want to experiment and kill it off when I was done. No additional cost required. I was very price sensitive back then. Being able to host many apps on the same $5 per month server was a huge advantage compared to hosting one app on one $5 per month Heroku app. I've also been a member of the Go community Slack since it was founded. Time and time again, helping people with Go, I had seen people wanting an example of a web application that used the Go standard library as its framework, and there was no really good example for it. I had also reached a performance optimization point where I didn't know how to make my site on Lapis run faster, so I kinda got nerd sniped and decided to rewrite my site in Go. The first iteration used a Go backend with PureScript and React on the front end. This worked for some time, but after I realized that my target audience uses weird browsers that don't support JavaScript sometimes, I removed the client-side rendering entirely, and I had the server spit out HTML to the client like a traditional website. This allowed me to survive Hacker News hugs of death gracefully, and is why I started putting everything into RAM in the first place. The Go port of my website handled the load like a champ. This is also when I started putting everything into one giant linked list. It was so much faster than using a cache server, but the main downside was that it made the site slower to start up. At the time, it wasn't a practical issue. I admit, my blog is an exceptional use case. My website gets a lot more traffic than you could possibly imagine. It usually gets more than 100 gigabytes per month. This is really impressive because my site mostly contains text and small images. When my articles get popular, they get very popular, very fast, and then that starts people looking at other pages on my website. I have really unique performance requirements. The number on the slide is the number of times I've been on the front page of news aggregators or have made other posts that have gone viral. At nearly 300 posts written, this means that my posts have a less than 1 out of 10 chance of getting a lot of page views in a very short amount of time, so I need to be sure that the website code runs as fast as it can for the most common use of the most common routes. At one point, my blog was starting to get loaded enough that it started to make my Doku server fall over. From plain text to HTML responses and RSS replies. Something had to give, so in a moment of weakness, I made a pact with the devil. I put my blog on Kubernetes as a part of me learning how to use Kubernetes for work. I'm a very hands-on person. I need a local copy of things in order to really feel like I understand how to use them. So I decided to commission a freight train to mail a letter, and I set up a Kubernetes cluster with DigitalOcean. This worked pretty great once I got past the initial teething issues, and it worked for a long time. I was disappointed by how many alpha components I needed to serve web apps reliably. I was able to do continuous deployment using GitHub Actions, and it made my blog minimal effort at most. I was focused on writing. Publishing was relegated to the machines. However, sometimes it blew up. And when it did, it was worse than when the single server blew up. I didn't have access to root on the servers. I had just enough apps on the Kubernetes cluster that I couldn't scale the cluster up and down to unbreak issues. Sometimes a file system mount would get stuck, and I didn't have a reboot that sucker button to unstuck it. When that happened, my Git server would stop working. This is a very annoying thing to debug while you should be focusing on your day job. After a while, I gave up. Then I got nerd sniped again with NixOS. With NixOS, I could just directly specify what should run and where. I had power beyond what mere mortals could attain with Docker and Kubernetes alone. I could shape the universe of the applications in question, and then proceed with that instead of trying to kitbosh things into shape based on overly generic tools. I could just use Nginx to route to the Unix socket, and then I did not have to care about the overly generic Turing-complete YAML hell that is Kubernetes. I think it's pretty great, but I'm a VTuber, so take my opinions with an appropriately sized grain of salt. The biggest thing that you can take away from this is that dynamic web apps can be very fast, especially if they are built to purpose. If you keep your goals in mind as you develop things out, it'll do everything you need very quickly. My blog stands on the shoulders of giants. Every one of these people gets a special shout out for helping either make my blog or this talk shine. Thanks. You all really help more than you can imagine. And thank you for watching. I'm going to stick around in the chat to answer any questions I haven't answered already. If I miss your question, or if you really want an answer to my question outside of the chat, please email it to howimadeblog@zserve.us. I'll have a written version of this talk, including my slides, a recording of the talk, and everything I said today on my blog soon. If you have questions, please speak up. I love answering them, and I am more than happy to take the time to give a detailed answer. Be well, all.
Hey, Z,
Hey.
very nice talk.
Yeah, thank you.
I laughed a lot when you compared Nyxt to Kubernetes.
Oh, yeah. Oh, wow.
Well, so sorry, you want to say something?
Fun fact about YAML, though. Did you know that it has problems with the abbreviations for Norway in Ontario?
What?
Yeah, so in YAML, true and false is not just true and false, but you can also use on and off and yes and no. And it turns out that Norway is no and Ontario is on. So if you have this list of, country codes or province codes, if you don't quote Norway and Ontario, you'll just randomly get true and false in there and your program will fail to load. This is very annoying to debug, for the record.
I didn't know about this one. It's very nice to know because people always sell YAML as, oh, it just works, gonna compile to JSON. Nice to know that it isn't.
I mean, it works if you don't do anything weird, but like when you get out of the realm of trivial things, you start doing the weird things, and yeah.
So cool. So Tom, which is helping us organize here the talk, he made a question: if there are any free alternatives to Heroku, because Heroku is ending plans in November. I don't know if you know how to answer, but it's his question.
I do have a suggestion there. One of them is try fly.io. I don't have a referral code, or I drop that and get free credits for my CDN, but yeah, fly.io is pretty good. They have a Heroku app importer, but in general, you're probably gonna want to just like get a cheapo instance off of DigitalOcean or something, and then you can do some hacking around with Doku or something.
Cool. Also, Bruno, which is helping organize the event, he said he's also a very hands-on person. Doing random things is great. And I must agree, I can't learn by reading. I have to hit my head on the keyboard and get the errors.
Oh, yeah. There's a very subtle joy in having bad ideas and taking them just that one extra step too far, because that just makes things so much more fun. Especially when you have like a terrible idea that should not work, and then you try it and it ends up accidentally being like better than the ideal solution you would have come up to when you were thinking seriously.
Yeah.
So I guess one lesson that you could take away from this is troll more professionally, because it makes computers work better. I don't know.
Yeah. But I think that's the definition of like thinking outside of the box, doing random things, and one of them work out surprisingly well.
Yeah, I'm still kind of like continuously amazed that putting everything in a linked list is as effective as it is. I never thought it would scale to this point. Also, that number of the times I've gotten to the front page of Hacker News is already out of date by at least 2. So,
very
yeah,
very nice. It's very cool that you're getting popularity. I hope your blogs continue to grow a lot.
Yeah.
And thanks a lot for the talk. Stay around if you're in the chat. You can make questions for the other people, or if anyone else make another question. Thanks, Z.
Thanks for hosting me. As if I miss you in the chat, there's the email address in the talk. It's howimadeblog@zserve.us.
Okay, thank you. So I guess our next talk now, Tom will help me, I think. Yeah, change speakers. We're gonna have Dev Messias. I don't know how will he present himself. I think he's gonna talk about Python abstract syntax tree. Hi, Bruno. How should I call you, Dev Messias or Bruno Messias? What's your favorite? Hey, Bruno. I think if you're talking, I think it's too low. We're not hearing you. I thought it was someone in the background.
Hear me better?
Yes, now we can hear you.
Okay.
Hello.
Hello. Yeah, you can call me Messiah's Messi, because every time that I arrive in a place, there is another Bruno that arriving first, like the Macabeus that organized the event.
No, very cool. Okay, so I'll call you Messi Messias. Okay, so have fun with your talk, and then I'll come back later with questions. from audience, and you can share your screen.
Okay, let me put here. Hi everyone, my name is Bruno Messias, and everyone's call me by Messi. And today I will talk about how we can use Python ASTs to find and create gambiarras. And I work as a software engineer at IDWall, and most of the time I work with Python, JavaScript, data science, and graphs. And because that, I need to deal with different projects with different code style guides and different persons from different backgrounds. And there is probably most of the people don't know what it means gambiarra. And here we have some pictures. Gambiarras are a quick fix to do some stuff in a faster or in a fun way that can be used to cook. In Brazil, you need to quickly escape from the Brazilian policy sometimes. And also when you run, for example, Python, the older versions of Python, there's some gambiarras in the code base of CPython. That there is this really good talk made by Alison Kupter. And this is the meaning of gambiarra, doing something in a quick way and to achieve a goal. Well, I want to start with a short introduction, and I want to start with some philosophy and some Russian literature. I think that everyone that study computer science for fun or academia found this statement somewhere. The limits of my language mean the limits of my world, which was made by Ludwig Wittgenstein in his first phrase. And this statement is very powerful because they help us to understand what we mean by a language and how we can understand how powerful our languages are. And we can bring this statement, I think, about some stuff that probably everyone already have some kind of headache with this and have some trouble. For example, when we need to find something in our code base, usually what we do, we type Ctrl+F, we type a pattern, and we pray to find the result of that we are looking for. But this is not good because I think everyone already tried to find a complex pattern in a code base, and this is very hard. For example, suppose that you want to find recursion patterns in your source code. Using just typing the code is completely unuseful. You won't achieve anything with that. And this is kind of a symptom of this, using a wrong language to do a task, a different task. We need to choose wisely which language we use to do that. And also, this statement of Wittgenstein brings some kind of philosophical meaning for language, because Wittgenstein started to think about language as a living beings. And because of that, we can also bring that to computer science. And we can think, our code base should be a living being or not? And when we bring this question, why we cannot write a code to write code for us? In this, we answer this question affirmatively. We are entering the realm of the metaprogramming. That will be one of the talks that I will talk in this presentation about the gambiarras. And I want to show two examples that are very common in data science, not using metaprogramming, because I think most of the people don't use that, but sklearn is a very famous library to do machine learning models. And there are two things that always annoy me. One of them is the grid search, which is a kind of machine learning technique to find the best parameters of a machine learning model. And the other, how we can combine different pipelines in sklearn. Those two trivial things, when you look carefully in the code base, you can find very, I will not say bad practice of code, but things that we can improve with doing some kind of gambiarra. The first thing was pointed me by a very big name in machine learning operations in Brazil called Michael Scott. He's worker for XP Investment. He said to me, look in the code base of Escalar in this file, and you will see some problems there. And I looked and I found a thing very interesting, because when we look in the code base, we discovered that Escalar validates the data for every call. And because of that, when we create a grid parameter source, for example, like the example that I showed you before, Escalar will call the validate data for each combination of parameters. And because that, if you have a grid of 1,000 by 1,000 of parameters, you have 10, 11, 1 million of calling validate data method. And there's a problem with that, because when you create a grid, unless you are a crazy guy, you will create a grid knowing that the grid is valid. And because that, you are just consume computational resource with no reason. We need to. It's not wise to do that. Imagine this for a real world model, a model with hundreds of thousands of parameters to source. This is not good. We can improve that. And about Russian literature, I think one of the most famous books written by Tolstoy is Anna Karenina. And Anna Karenina starts with a sentence that is that this sentence: happy families are always alike, and every unhappy family is unhappy in its own way. And why I bring in Russian literature for a talk of computer science for programming language? Well, because Anna Karenina is a really powerful book, because the Anna Karenina created the principle of Anna Karenina. And which is, what is this principle? This principle, the people start to notice that this principle that Tolstoy bring to the book is more common in different areas of the humanity. For example, when we study statistics, we have an Anna Karenina principle related with the violation of the null hypothesis. And because that, we have an Anna Karenina principle in data science. And also, we have an Anna Karenina principle in the catastrophe theory, for example, in engineering, and when you are trying to build a really complex system, the Anna Karenina principle appears in this area of knowledge, because when you think about Anna Karenina, we think that we need just one violation of a set of rules to create an unhappy situation, or a situation that no one wants to live there. And there's another areas of human knowledge that study the Anna Karenina principle. And I want to bring that to code quality analysis, because when we start to think to bring this kind of principle to coding, we can create some questions, very simple questions. For example, are all projects alike? Obviously not. And the other question that we can, I think everyone that works with different languages have some trouble with that, when we need to create new rules in some linter. For example, in Python, Flake 8 is the most famous. It's very hard. And the other thing that we can bring the Anna Karenina principle is because the Anna Karenina principle put a statement that we need to define a set of conditions to define a happy family. But we have some problem with that. Who defines this set of rules to a family to be happy? And we can think about that when we think about PHP 8, when we think ASLint in JavaScript. All those code style guides are created by some software engineers from very specific companies. And we can think that is this right? Because a set of rules created by those people not necessarily is good for everyone. And we can see a really clear example when we look for Python and PHP 8, because Python has a really nasty feature or bug called mutable defaults. And here I have a link to, let me show you. Happily that we can see the mutable defaults here. No. I delete the example. Oh, I delete the example. Sorry, I delete the example. But the mutable defaults is like, let me show here. Mutable defaults is when you create a function, and in this function you pass as an argument, a default argument. One of the arguments are mutable, and because of that, the Python, the function behaves like as the function has some kind of memory about the previous calls, and this is very bad because we don't want that functions have side effects or have some kind of strange memory about your application. But for some reason, the people who created the flaky 8 and create the PHP 8 style code guide choose that this is not a pattern to be blocked by the linter, which I think this is very bad. And when you try to extend that, when you try to create a new rule in Flake 8 to block this behavior, we have a trouble because it's very hard. We need to create a package. We need to create a specific source code using ASTs, transformers, and so on and so forth. This is hard. We can escalate that for several rules. And this is bad because when you think about Tolstoy, Wittgenstein, this is not a good language. This is not a good way to do that. This is not very happy to do that. And we're thinking about this famous meme that we have just two options, or we became very serious about following the PHP 8 rules and using linkers like Flake 8, ASLint, or we don't give we don't complain about that, we don't worry about that, and we have some kind of happiness in our code base. But this is not good. We need some kind of equilibrium point between the two approaches. And what I'm proposing here is that we have an recurring principle in code quality analysis. I think this is clear. And I have a solution to that. I developed a solution based on this principle, in this philosophical principle that I call it PyAsterix. And I bring this solution with a simple statement that simple projects are all alike, and each complex project is complex in its own way. And when I start to develop PyAsterix with this principle in mind, I choose to have flexibility to define new rules and information in linkers. I also choose that if someone wants to change my linter, this needs to be very easy. They don't need to code a specific package for that. It needs to be made very easy and fast. And the most important one, I will not say for no ones which is good and which is bad. It depends on you. It depends on your project. And I think this is a more happy situation. And doing that, we have some kind of equilibrium point. And here we have an example how PyAsterix works. Here I created a specific rule to block the mutable defaults. And here you have an XPath that because PyAsterix works using XPath to find the patterns in your code base. And it's very easy. Instead of writing almost 100 lines of code and create a Python package, we just need to write just a single line of XPath expression. Well, this is the introduction of my talk, and I will go to the summary of my presentation. The first part, I will talk about how we can create gambiarras, and I will bring some questions and bring some understanding about the Python ST and metaprogramming. And also I will show the specific case that we can use AST to create this kind of gambiarras in Scala. Second part, I will talk about PyAsterix. And PyAsterix is kind of a tool to find gambiarras with the same techniques that we use to create metaprogramming in Python. And because that, I will talk a little bit again about the anchoring principle, the correct limitations of the code analytic quality tools. And after that, I will talk about a little about future. Well, the part one, I think the most important question that creates some kind of noise in the Python community is if that Python is an interpreted or compiled language. Well, when you think deeply about this doesn't make so much sense today because most of the compiler, most of the programming languages use kind of a mix between a compiling and an interpreter phase. And I recommend this really good publication and very funny that use some kind of cartoons to explain that. And the answer is that Python is both compiled and interpreted. And this is good, very good, because when we look into the pipeline of how a piece of Python code is compiled and interpreted by the CPython virtual machine, we have this. And the important part for this talk would be just that, which is the compile phase of the Python machine. And here we are focused on this guy, the ST. And what is a ST? Let's go back to the human language. When we think about sentences in human language, like Portuguese, English, one way to analyze a sentence in a formal way is to break the sentence in small blocks, and each block has some kind of specific meaning, has some kind of specific structure. This structure that I'm showing you here is called syntax tree. And when we bring this concept to computer science, this is called abstract syntax tree. And why this is powerful? Because when we have abstract syntax tree, we have some kind of formatted structure to analyze and to change our code. For example, here we have a very simple piece of code of Python, and I'm showing you how you can see the abstract syntax tree. And I want to I will give some spoilers with PyAsterix, because PyAsterix is a tool to find gambiarras, but also a tool to understand gambiarras. For example, here I will call PyAsterix to open this file. And I will show you the abstract syntax tree of this piece of code. And here you have the abstract syntax tree. It doesn't seem very good. It doesn't seem very easy to understand, but I assure you that it's easier to manipulate this than manipulate a piece of code to do metaprogramming. And when we look at the representation of this abstract syntax tree, we have this for this piece of code, which each element here in blue is a node of the abstract syntax tree. And this is at a very important point, what is a node in abstract syntax tree? In Python, a node is a class whose base class is ST. A node has attributes in Python, and each attribute can be another attribute or a field. And ST is just a tree of nodes. Well, in Python, ST attributes can be a line number, can be a column offset, can be the end of the line number, and can be the end of the column offset. And each field in a node can be also another node. And this is important. A field can be a node, and can be an atomic type, like an integer, a string, object, or a boolean, or a makefile. We have more different fields in Python, and you can look for the different fields in the full grammar specification of Python, or in this post that I made some time ago to talk a little bit about Python STs. Or but my best recommendation is this book, which is a really good book about the CPython virtual machine, and you can find everything inside that. Well, let's dirty our hands. Let's see how we can do this kind of manipulation with the code metaprogramming using manipulation of ASTs in Python. Well, I show you this example. I say this is very bad because this call every time the validation data function in sklearn library, but we can do better. We can ask it to to Python to manipulate the code base and change the sklearn code base for us. And how we can do that? Well, Python has the ST module, and the ST module has this guy, node transformer. And this guy is like a walker who will walk in your abstract syntax tree and will visit each node of your abstract syntax tree. And each visitation is defined by a method. For example, here we have a visitation in a node that has a call type. And what we can do to perform metaprogramming in Python is asking to this node transformer class every time that he finds a node which is a function and which has attribute validate data, we will ask it to this guy the following. Well, pick this node related with the calling of this function, copy all the information about the location of this node in the code base, and we will ask him to replace with a new node. And is that what I'm doing here? I create a new node which does nothing. It's just call the function, but just return the same values that I passed. And I will ask the guy to replace the node. I don't want the node from sklearn. I want my node. I want my metaprogramming task. And when we do that, we have a really good, we can improve the performance of sklearn because we can remove these unnecessary calls with just dumb calls. And how we can transform the code back to AST, back to a source code? Well, it's very simple. Here, I just ask it to the Python spec module to get the source code of the base.py. And after that, I created the abstract syntax tree that here I call a tree method. And after that, I create a transformer using this class. And then after that, I ask it to my transformer to visit my tree, my abstract syntax tree, and do this kind of replacement. And after that, I can replace I can transform back the abstract syntax tree to a source code in sklearn. The other thing we can do is introspecting. Now let me show here. The other thing we can do that is is because, like I said, in sklearn we have this kind of pipelines and function transformers, but they are very rigid and very hard to understand what is happening behind the doors. And what you can do is create a kind of a node transformer that will introspect in the function and will extract the information that we want in this pipeline to create some kind of plot using matplotlib or perform some kind of statistical measure. And this is this is a little bit hard because we need to compile the function. But the message that I want to pass you here that when you use node transform, when you use ST manipulation, you have a powerful way to manipulate your world. You will be jailed by restrictions of sklearn or any kind of library. You can improve your life. You can be more happy with your code base. Well, and I think this is a solution. And as I said before, we can think that if this solution is good or not, or if it is very dirty. But the question is very simple. Should we always take Python seriously? And I think the answer is not. If you want to understand why I put this image here, you can watch the talk made by Alison Kaptur. And I think this is good. We should take Python serious, and because of that, we can do metaprogramming without any kind of rules about being too formal. Here I have a set of different links that if you want to see more interesting things, how to use AST manipulation to improve your life. Now, the second part, I talked before about how to create gambiarras with AST manipulation, and now I want to talk about how we can find that. And this very common because I think every software engineer, every data scientist, constantly check the same pattern in a merge request review, especially if you have a lot of people that started a new position, and we need to do that several times. And it is very bad because we are just when we do that, we are just a human linter. We should do that. We should delegate that for a software. And we bring back the Untitled principle because every time that we check a merge request and this was not blocked by default by the pipelines in our repository, we are seeing the Untitled principle. And PyStrix do this in a very clever way because what we do, I will show how do we how PyStrix does this task, completes this task without creating too much noise in your mind, because he's very flexible to defining rules. It's easy to configure, and I will not make I will not say who is good for you or not. And how PyStrix works? Well, as I said, we have a YAML file that is here. This is the configuration file of PyStrix, and here we have several parameters that we can configure. For example, if you want to have interactive files, if you want to normalize the AST, I will talk about this a little bit. If you want parallel execution, if you have a quiet output or not. And here we have the rules that we are defining our hack code base. And here, for example, we have the mutable defaults that I talked before, but I also have this simple method to find recursion patterns in class definitions. And see that is very simple. We can create several rules here. And for example, if I want to open PyStrix with a specific file that I already showed you, but we can also open the PyStrix in a directory. No, here. Sorry. Here I'm opening PyStrix in the dummy examples directory, and I will asking for a PyStrix, for example, to source using all the rules that I showed in the file. And here we have the patterns that they found. For example, here he found a use of built-ins in the definition of function, use of mutable defaults, and so on and so forth. And we can also source using specific set of rules. For example, we can type, if I want just to look for defaults, I can just type defaults. That is, I will explain that. And he will look for the mutable defaults in the code base. And how PyStrix works? Well, I think everyone already worked at some time with XPath, and XPath is a language to find patterns and extract values from XML files. And XPath are very common in web scraping. I think everyone who opened the inspector elements already knows the XPath expressions. And we can bring that for code quality analysis, because when we think about AST, obviously AST is a tree. And XML can be used to represent a tree. And we know that we can use XPath to easily navigate in an XML file. Well, the solution is quite simple now, because if that, we can just analyze your code base, not using the solutions like Technocracy that use the AST node transform, but instead of that, we can use XPath to understand your code base. And how we can do that is because here I have the client interface of PyStrix, and I will show something here. I will open a file here that I want to analyze. And you ask about, here I have some pop-up
Hey, Bruno.
options. Show,
Sorry to interrupt. Just to say we have 5 minutes to the next talk. Just to give
okay.
you the timer.
I'm finishing. Yeah, here we have some top options, and we can see that we have option to show AST and show XML. And what is this XML? Is a representation in XML of the abstract syntax tree. And this is far more easy to navigate and to look for patterns in your code base. And we have this, and the Plastics has a really friendly interface. You can select the specific rules, you can navigate in the files. And here we have the example about the transformation of the AST in an XML AST. And that Plastics was developed with the idea to be a linter to be used anywhere. Because when you think about Python 3.7 to 3.8, each version of Python has a different grammar. Like Portuguese and Brazilian Portuguese have different grammar. But we have we formed some years ago that put all the languages in the same background. And we have that in Python. We have a library called Guess that can normalize the ST and turn each ST in the same, using the same grammar. And because that, we have some kind of unified ST representation for any kind of Python source code. And what do I do after that? I transform the ST in XML. And after that, instead of using pure XML, I use LLXML that allows us to create LLXML extensions that can create arbitrary functions call inside of the XPath, which is very good. And after that, we have happiness because we have very powerful tools and techniques to analyze our code base. In the future, I hope that we can bring some plugins, for example, to be used in Rust, JS, and C. And that here I put the link for the plastics if you want to contribute or look for more information. As I said, I work for IDUAL. They have open positions available. If you know Portuguese and English, we are welcome. And that is. You have enjoyed, and if you want any doubt, you can reach me on email or on my website.
Hey, thanks a lot, Bruno. It's very nice talk. And
okay, thanks.
I think one of the things you mentioned that is I think is a nice thing is philosophy and literature is not outside programming. You should do that because it adds up a lot to programming.
Yeah, I think that we should ignore that, and I think it's a better thing when a programmer or a software engineer ignore that she needs to study philosophy, she needs to read some books, because the big guys always do that. They always study things different from of a computer, of math. You need to scratch your mind.
Yeah, thanks a lot again. We're up for the next talk on time, but thanks a lot for the detailed talk on AST for Python. I liked it. And I think now we're gonna have network technocracy. So Tom, if you could help me do the switch. Thanks. Hey,
hello.
Hi Rodrigo.
Hi there.
Thanks for coming today. I'll let you do your talk, and then we talk a bit later if we have questions and we chat a bit. Okay?
Sure. Let's go.
Okay, thanks. So let's start with Rodrigo's talk. You can share the screen.
All right. I'm sharing the screen. Can you see it? Right. All right. Hello, everyone. It's a pleasure to speak here at GambiConf. I'm going to talk about thing experienced. At the time, my only option for connecting to the internet was through Internet Service Provider, or ISP for short, which imposed, or at least tried to impose, some quite strange, to say the least, limitations on how their customers their own network. This is happening, and I was not actually planning to turn this into talk as the thing were unfolding. So I did not.
Hey,
Therefore,
Rodrigo, I think your connection is cutting a lot. I'd recommend maybe you shut down the video because the video is stuck, so we can hear your voice and the screen share.
all right. Looks like I
Or
had
if you have
a
another
not
connection.
Looks like I've got a bug here. I'm not able to switch back to the previous to the restream tab. I have to. I think it worked now.
Hey, no, I think still. If you want to reset like the entire setup, you can just leave and re-enter. Maybe it fixes.
All right, all right.
Let's wait for Rodrigo to come back then. Hi. I don't know if you're speaking, but I'm not listening to you if you're speaking. Yeah, I think. Are you there? No, I don't think it's working. Well, what we're gonna do then is we're gonna talk to Rodrigo and try to fix his issue. And since the next talk we have it recorded and it's a talk about Hyla, she's gonna talk about research and design code base. She migrated from Bitbucket to GitLab, and I think we're gonna go with that one then, and then we can talk to Rodrigo and try to fix his infrastructure issues while we go with Hyla's talk. So now we're gonna go with Hylas. Then I think she won't be here. So Tom, if you want to start her talk, we can go with it. I think with chat in the.
Hi everyone, thank you so much for joining me. Writing code is something that we learned, right? But managing a project end to end, probably not that much. In this talk, I will share my journey of migrating an entire R&D codebase from Bitbucket Cloud to a self-hosted GitLab on my own, but with the help of great people along the way, of course, planning, implementation, and handoffs. I will share best practices for managing a technical project end to end, with a lot of key takeaways that you could adopt so your project will be handled smoothly and successfully. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. I recently joined AWS Community Builders. I'm co-organizer of conferences in Israel where I live, DevOps Days Tel Aviv and StatsCraft. I'm a mentor in courses and communities, DevOps culture fan. I think this is what helps companies achieve great things. And I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. Okay, so this project took, all in all, from start to finish, 1 month and a half. Is it a lot? Yeah, no, you tell me after seeing this presentation. So the project structure looked something like that. Starting with planning, so what to think about, things to consider, foresee bottlenecks and tackle them up front, deadlines, etc. Then the implementation phase needed considerations like integrations. We had Jenkins, we had Jira, so all of these thoughts. Security aspects, handling expected blockers and leave room for the unexpected, of course. So everything for the implementation was in this phase. Training for the R&D department, they didn't know anything about GitLab, so I had to allow them a way to be familiar with this tool. Documentation and handoffs. So usually I leave documentation behind because I want people to know what I did. But fun fact, the company that I did this project for, I left this company shortly after finishing this project. So it was really important for me to leave documentation behind because I wanted them to know how to maintain GitLab while I'm gone. And hovering above everything is project ongoing statuses because, hey, they want to know what's going on, especially because I did everything on my own. They need statuses, my managers. So always I gave them statuses that they can be at ease of what's going on. So before the planning itself of the project, there was actually a pre-planning phase. So when I got this task, I first started asking questions like to understand the scope of the project, right? So first of all, what is my deadline? And also, why are we doing this migration? Because that way I can make sure the project process and the outcome is according to the management needs and requirements, right? Also, do I have any limitations? Like, do we need to do or want to do things in a certain way? For example, GitLab has two deployments, Omnibus, which is the VM installation, and Helm release for Kubernetes deployment. We at that company used a lot or used heavily Kubernetes, so we naturally selected this deployment, but there could be a lot of limitations or a lot of things to consider that will affect the planning. So we need to think about that before we start to actually plan the project ahead. And speaking of planning ahead, a goal without a plan is just a wish, right? So we need to have a plan. And once I felt like I have enough information to go on, then I created a high-level plan. So this was the plan. Okay, cool. But it is great for me, the executor of the plan. But management wants milestones and due dates. This is how they can measure progress and convey status in a clear manner. So that's why I've taken my plan and converted it to be actionable and measurable with setting up milestones and due dates. So let's see. The first milestone was the Terraform code. In this phase, I created the Terraform code for the GCP projects because we worked on GCP, Google Cloud Platform, dev and production. Also, Terraform code handled the GKE, the Google Cloud Platform Kubernetes offering. It handled that and the GitLab deployment, the Helm release. I'm gonna speak about it a little bit later. So everything in regards to the Terraform and the infrastructure prerequisites and the actual GitLab deployment was done in this phase. Then networking troubleshooting. So since networking was handled by a different team, I automatically added a dedicated slot for troubleshooting since it involved not only me, right? And it doesn't mean that network troubleshooting was restricted only to this phase. I had to troubleshoot issues throughout the project, but I tried to map every source destination that I could and have it all checked out in this phase. The next milestone was GitLab up and running, including DNS name, certificates, and some integration, everything that says GitLab is ready to go. Next milestone was first bare repo migration. So I had to use the GitLab migration feature in order to import the repository from Bitbucket to GitLab. I had a lot of issues. I created a lot of tickets. Some tickets, the support people said, hey, we already have an issue opened, and some they fixed, but it took them some time. So it was a lot of ping pong until the actual repository was able to get created properly and work with it. So everything about that was in this phase. Next milestone was peripheral infra backups and monitoring. So usually, or not usually, I don't know how you do things on your end, but backups and monitoring are stuff that you leave to the end because it's not that important as the deployment itself, right? Because we want to keep moving, we want to do things quickly and to achieve a platform that is working and have the backups and monitoring after that, right? But think about it. This is source control management that we talk about. This is the code of the company. So because it was super crucial and we are the ones to manage the code now, this part of the implementation had to be done in an earlier stage. So backups and monitoring were introduced and I checked them over in this phase. So backups and restore, both on full system of the GitLab and repo level and branch level. And not everything was documented well on a GitLab side, so I documented it on the documentation that I left after I was gone. Monitoring, so system monitoring and also application monitoring, the GitLab metrics. I'm also gonna drop something about that on the implementation phase afterwards. And also in this phase, I tried to concentrate also the second and last part of networking troubleshooting. So SSH and HTTPS from several sources were checked and fixed in this phase as well. Next milestone was the second repo migration with the pipeline, because At that time, we migrated to GitLab only as an SCM, source control management, and not as a CI. So we had Jenkins, and we need to have Jenkins communicate with GitLab and pull the repositories from it and push and stuff like that, right? So everything that is related to this integration was done in this phase. Jenkins integration itself, the configurations on Jenkins and GitLab side to make it work, and actually everything that is needed to test fully Jenkins against GitLab repo was done in this phase. The next milestone was training gradual login and continuous migration. So training for my team that needs to maintain it, but also for the R&D that needs to use it. So I gave them initial intro on the main features. I'm gonna show more about it later. Gradual login. So how GitLab works, once you set up some integration, you can log in with your Summon integration, but GitLab needs to create an entity first on GitLab side in order for us, the admins, to link between the entity and the permissions. So I knew that I have to tell the R&D, hey, please start to log in so I can start and set up the permissions, because I don't want to do it in the last minute, right? So on the training session, I show them what they need to do along with the actual platform, and I encourage them to log in to dev and then to production. So the user will get created, and then I can set up the permissions. So this was done as well. And since I already migrated to repositories, I know I got the hang of it, and I can continue with the migration of all repositories that we had. So I divided all repositories to teams, so it was coordinated with each team when the repositories will get migrated. And last but not least, the last milestone was migration done, documentation and handoffs. So I migrated all repositories until that point, except for the backend repo, which was big and important and the most crucial one. So I had a educated decision to leave it to my weekend, and in Israel, weekend is Friday and Saturday, and let me tell you, it was a happy Sunday after that. So I didn't want to disrupt backend and have them wait, because I saw that on dev it took a lot of time to import this repository, several hours. So since I didn't want to make them be on a strike or something like that, then I did it on my weekend, and that's that. And then I finished preparing documentation and handoffs. I say finish because I prepared it throughout this project, because I knew that I wouldn't remember what I did at the beginning. So I added bits along the project, and then in this phase I just finished and added some more stuff. So the documentation was for DevOps to maintain it, and for the R&D, how to change the local repo to work with GitLab. So that was the plan. And I've created a planning doc that consists of the milestones that I just showed you, plus these extra sections. And I decided to put them all on that document to have one place that have all aspects referenced. So first steps, a mapping of needed steps on my side and external teams. So I can lay it all out and see what can be done in parallel and what should be done ASAP to reduce bottlenecks later on. To do, out of scope high-level tasks, things to do and remember after this project is finished, like stuff that relates to the CI or anything else. Read more, things to dwell on and deepen our knowledge in, because I had a lot of things to read and I knew that some are important right now and some are not, so I put them aside. And things to think about, considerations for annual audits and stuff like that. And some more addendums to the planning doc, because why not? Report issues that I've encountered both on GitLab side and on our side, internal side. They were listed, of course, on Jira tickets and stuff like that, but again, it was a centralized place to see any issues that we have that could potentially endanger the project's timelines. And more things, so access mapping, inbound and outbound accessibility to Bitbucket, so we can do it also for GitLab, LDAP groups for the login, and main repositories and CI pipeline to track the progress of the migration. Okay, so we talked about the planning, right? So that's good, but we need to remember that I did this project on my own. And since I worked on this project alone, it was very crucial to update my managers on the status so they can report back to their managers and to show them that I'm progressing according to the needed timelines. So I had weekly meetings to update my managers on the progress, plus ad hoc meetings with updates on blockers, like either issues that I need their attention and help to escalate, or just an FYI, like this is how I'm handling it, if you're okay with it, so it's just an FYI. And me and my managers created Jira tickets for everything that I did, and I added detailed updates and current status on each one. I created more tickets along the way, of course, so there's communication is key in this particular scenario. And the thing that we need to remember is that information is power, and information, when delivered properly without overbearing the recipients with details, can help ease the decision-making process, deliver a feeling of stability, and allow your ongoing independence of running the project, which is super, super important, especially when you're working on a project alone and you don't want to have any more bottlenecks. And also, another thing that I want to mention is that I had a meeting with the R&D team leaders to prepare them for the migration and explain what is going to happen, plus involve them in the folder structure decision because I wanted their input as the code owners. But not only that, I wanted to make them feel that they are a part of it. And that way I knew that I will have their cooperation later on. So this was basically the most important reason why I actually did this meeting. Okay, so let's talk about the implementation. So as I said before, Terraform code that created the projects on GCP, dev and production, and GitLab has Helm release. So since we use Terraform, I had to do a little bit of tweaking to incorporate the Helm release in the Terraform code that we had. And another thing that is very important to mention is that GitLab was very and totally new to me, okay? So I really had to rely a lot on the documentation, since my tight schedule didn't really allow enough time to play with the system and do some trial and errors. And reading the documentation is really, really important, but also considering trade-offs like, okay, this is a must read now, but this could wait until I have more time. And then I put this in the section of the planning doc of what else to read, right? So a lot of things that needs to be thought of was on that planning doc. And also, again, I can't stress enough reading the documentation, especially when you have tight schedule, because only because I read the documentation, I decided to do a couple of things. So let's go through them. First of all, I used DB version X and not Y, because the documentation stated that if I use that version, it will prevent later maintenance, because they plan to use the next major version with that DB version. So if I didn't read it, then I will force my team members to do a maintenance after that. So it was very important to do. Another thing is that I haven't implemented the high availability feature because it wasn't GA'd yet. Another thing was the monitoring. So monitoring wasn't baked for the Kubernetes offering yet. So I basically did it myself. I went through the metrics documentation. I added dashboards according to what I thought was important, and alerts based on those metrics. Backups. So they had backup for the DB itself, but they didn't have backup for the secrets that is used to restore that DB. And they say so in the documentation. They say for the DB backup, you can use our cron job, but if you want to backup the secrets that you have to use in order to restore that DB, then you should do this backup yourself. Why? I don't know, but I did it. So I created another cron job manually that backed up this secret in order for the DB backup to be viable, right? Because without that secret, I can't restore. So it was very, very important. And only because I read the documentation, I saw that. Another thing is that once I started this implementation, when I deployed the Helm release, I had a lot of issues. Like I tried to upgrade and then I had some issues and I couldn't find the reason online. And the thing is that secrets and the PVC are coupled and dependent. And when I tried to upgrade Helm, I did an install and I removed the secrets as well, but I didn't remove the PVC because, hey, I want the data, right? And then there was a mismatch because, again, secrets and PVC coupled. So also something that needs to be bear in mind, that when you deploy the Helm release, don't do uninstall or don't remove the secrets, the Kubernetes secrets, leave them, because when you do uninstall of the Helm release, they stay, okay? And I didn't know that back then, but it was for a reason. So there's was the fun facts about the implementation themselves. And also a fun fact, GitLab changed the official documentation due to an issue we raised during implementation once it was almost production. So I don't have much time to discuss it, but if you want, I can tell you about it later. Okay, so training. So GitLab again was a new tool that the R&D department didn't know, and also the glossary was different. Pull request is not there yet anymore, it's merge request, and I didn't want to spring it up on them and expect them to feel comfortable using it from day one. So that's why I had a training session, because I wanted them to be familiar with GitLab before they start to use it. I also had an onboarding doc to tell them how to change the local repo from Bitbucket to GitLab. And yeah, you can find it online, but I wanted them to feel that they have support, and that's why I did it, and have a quick adoption, of course, and a dedicated Slack channel for the R&D to raise questions and bugs and support all GitLab related issues, because again, I want to give them a sense of support. Documentation and handoff, I already mentioned it a bit before, but I covered everything that I could in order for the DevOps team to maintain it, from how to deploy a new version of GitLab to how to manage it and replace certificates, and even how and what information to provide to GitLab support when you are opening a ticket to prevent ping pong. So everything that I could, I shared in this documentation that I left behind. Okay, so I covered a lot of things here, right? So let's see, what can you take other than the bits and pieces in regards to GitLab itself? What can you take about managing a technical project? So planning is a must, right? And to understand the company's needs and why this project is important, and use this information to try and foresee any bottlenecks and plan how you're going to tackle them upfront. Also derive the deadlines based on all the information that you've gathered, and then execute accordingly. Structure will help you achieve things in timely manner and literally progress according to plan. Updates and collaboration matters. It doesn't matter if you're working on a project alone or with others. You should always involve and bring the stakeholders up to speed, managers, other team leaders that are affected by this project, etc., including regular updates and raising flags on issues. Brainstorming and collaboration matters, point 2. So it's always best to showcase the technical implementation you're planning to your team members and manager to A, make them familiarize themselves with the project since they need to support it later on, the platform, and B, to see if they have remarks on things that you haven't thought about, to make sure that the implementation that you will do will be as best and suitable for your use case as possible. Next key takeaway is that trade-offs are a given, right? Deadlines and mandatory and nice to have implementations are always things that you need to consider. So make sure you execute based on that. Because yeah, it's fun to play with the cool features that the UI has, but if you are under a tight schedule, you should focus on what matters right now. Documentation is key. I couldn't stress it enough. Both the documentation that you read while implementing technical and logical aspects, and also the documentation that you leave behind. So the documentation for the implementation will help you take the right decisions and defend those decisions whenever needed, and the documentation that you leave behind, knowledge sharing is important. And last but not least, change is hard, and when people are used to working in a certain way, you need to take that into consideration, and when you plan the project, especially if it's a migration project. So make sure you leave time for training and familiarization with the tool. So thank you so much. I really hope that you enjoyed it. I know that I spoke quickly at times because I didn't have much time. If you have any questions about GitLab, I will try to answer as much as I recall, or about technical project, or about any SRE topics, I will be more than happy to help. Thank you so much.
Hello again, and Hyla. I think it's Hyla. Sorry if I pronounced wrong. Like, she's not here to ask, but she's on the chat actually, just not on the call. So if you have any questions for her on her journey from Bitbucket to GitLab, feel free to ask, and she can answer here. And thanks, Hyla. I think it was great. I like that you show the many angles from changing the tool. It's not just like the code. It's like you have to align people and all the processes you show. It's many steps, not just, oh, let's change tools. So it was a really nice journey. Thanks again for sharing. And again, she's in the chat. If anyone has any questions or want to talk to her, just send on the public chat. And okay, so the next person that will talk now will be Rodrigo again, because I think he fixed the issues. Hello, Rodrigo.
Hello.
Nice to see you here again. And I hope,
Sorry about that.
you can screen share. No, it's no problem. I hope you can go fine now.
Yeah, I'm going to try to turn off the video here while presenting. And let's go. Hello, everyone. It's a pleasure to speak here at GambiConf. So today I'm going to talk about something I have experienced a while ago, when my only practical option for connecting to the internet was via an internet service provider, or ASP for short, which imposed, or at least tried to impose, some quite strange, to say the least, limitations on how the customers could manage their own networks. So as this was happening, I was not actually planning to turn it into a talk, so I did not extensively document it at the time. So I might not be able to show you any actual screenshots or pictures, but I did have a few online conversations about this with some friends at that time, which I have been able to find and read through them. And so I'm pretty confident that everything I'm going to show here is a very accurate representation of what happened then. I must also note that I have chosen to omit some identifying information about people and companies involved in order to avoid potential trouble, since we will be discussing some mildly sensitive topics, but in any case, I hope you enjoy it. Let's start with some contextualization, right? So right off the bat, when I got the service from that ISP, I did a little bit of testing, mostly with traceroute, which quickly led me to figure out that their infrastructure looked like something like this. So an Ethernet cable from them came into my house. That was just a regular Ethernet cable. It was not like those ones from cable internet. It was just an Ethernet cable, and that I figured out via traceroute that was connected to a switch from the ISP, which was shared between myself and other customers living nearby. That switch was connected to the cloud, which, as anyone who has seen network diagrams before know, simply represents a patch of network that are relevant for the discussion at hand and therefore are not illustrated here. So what the problem was? The router the ISP has provided me with wasn't really like one of those modems regularly used by cable and fiber providers. It was simply an off-the-shelf SOHO router, which, and SOHO means small office home office. It refers to those small basic routers that most people have at home, which you can find pretty much at any consumer electronic store, like the one illustrated here from TP-Link. Please note that this is only example, right? The router that was installed for me wasn't really a TP-Link model, but still, that's pretty amateurish service, right? But there's more. You see that ISP did not actually provide the customers with the username and the password for configuring those routers they installed. And this was a huge problem since besides me not being able to apply firmware updates, customize settings, and things like that, they set up those routers with Wi-Fi enabled and standard SSID and a password which you could brute force very quickly. I had a friend who lived nearby. He was a customer of that same ISP because they were like the only ISP which was available in the region. And I confirmed with him that the password they set for the Wi-Fi, although it was not the same for everyone, followed the same pattern. Which means it will be even easier for an educated attacker to figure out. It was something like 4 letters and 4 numbers. It was pretty basic stuff. Since the ISP did not provide us with access to the router's configurations, our only options for changing the password was actually calling their support service and requesting a change over the phone, which is also pretty terrible. First of all, because it implies that every support worker of that company has access to your router settings, which is pretty dangerous. Second, because you are going to have to say your desired Wi-Fi password to a random person over the phone. And third, because this makes it practically impossible to use lengthy random passwords such as the ones generated by a password manager. Like just think about having to read a 64-character random string to someone over the phone. It's not possible, right? So I started thinking that maybe I could perform a factory reset on the router, even though the ISP had put a safety seal over the reset button. But I talked about that with that friend of mine. He said he had attempted it before, and it caused his connection to stop working, and he ended up having to call the ISP to send over a technician to set it up again. So the question was, how did the ISP actually authenticate the router? Because reset should not cause things to stop working. My first thought was that was probably MAC address filtering, but that should not have stopped working with a simple reset. And so there must have been something else. In any case, I took a look at the stickers on the other side of the router. I found out its MAC address. I cloned that to my PC, and I tried to connect my PC directly to the Ethernet cable coming in from the ISP. That did not work, so I started looking around at the operating system network settings so I could try to figure out what was happening. And it turns out that I was not getting any IP address, which means this network was most likely did not have a DHCP server, and all the connected devices were probably using static IP settings. So how can we get the static IP configuration from a router that we are not able to access, right? I cannot simply log into its web panel and get the IP address from there. So what do you do in this case? This is what is the idea. Do some network sniffing. So I turned off the router. I connected its WAN port to the Ethernet port on my PC, and I started up Wireshark, turning on again. The router began broadcasting our packets, requesting a MAC address for what I guess was its default gateway. And this is what our packet looked like. Here you can see a router. In this is just an example, but the router here would be this device, which has the IP address 10.0.0.1, and I'm sorry, it would be the device that has the IP address 10.0.0.2, and it was requesting the MAC address for its default gateway, which was most likely 10.0.0.1. And so, via this R packet, you can pretty much see what the router IP address was. It also sent this MAC address, but we already knew that from the stickers on the underside, and we could figure out the default gateway IP address. From that, I just guessed the network mask at that point, and from that, with that information in hand, I connected my PC to the ISP's Ethernet cable once more. I used the same MAC address and static IP address settings as those that I got from the router from the R packets, and it worked. I could successfully connect to the internet in that manner. So, From that, based on that experiment, I knew I could replace the router the ISP had provided me with one of my own choosing, as long as it allowed MAC edge spoofing, which, for instance, MikroTik devices, their home routers allow you to do that, allow you to do MAC edge spoofing. So I set up one of them in place of my of the ISP routers, and that was it. I had complete access to the settings. No employees of the ISP had any means to access any administrative interfaces on the router anymore, and I could set up Wi-Fi networks following the best security practices. I wonder if at some point someone at the ISP would notice what I did, for instance, by noticing that they did not have access to the router anymore, and if they would complain to me about it. That never happened. Nobody said a thing. So either they never noticed it or simply did not care. So that's it. Is that the end? Uh, After all, I had to gain control of my network segment. Everyone was happy. That's the end of the story, right? Well, it could have been. You see, after I replaced the ISP router, it was just laying around with no use whatsoever. And as time passed, it started growing me that getting its password would most likely be a fun challenge. So I set out to do it. And I started to consider my options. I thought of attempting to use like some software exploit. So I started searching on the internet. I could not find any documented vulnerabilities affecting that specific model. And as I only had access to the login screen, the attack surface I had for attempting to find them for myself was quite limited. Uh, so I started thinking of maybe opening up the device, dumping its flash memory, maybe attempting to find some debug headers. And here's the fun thing. Even though the ISP had put a safety seal over the reset button, they hadn't done the same for the screws. So you could open the device up, reset it, and do anything else from the inside without disturbing any safety seal at all. But what made me hold back from going down the route was that I wasn't confident enough in my manual abilities to guarantee that I was not going to damage the device while attempting soldering and stuff. And I was contractually obligated to give them back the device once I was not a customer anymore. It could give me some headaches if I did any physical damage to it. So, what alternatives were there left? Uh, so I started thinking about how did they remotely manage the router settings. Now, regular modems usually do offer the ISP dedicated tools for that, like, right? So, like implementing support for the TR069 protocol. But this was not really a modem. It was an off-the-shelf Soho router. It was certainly not even designed to be used as the gateway between the customer and the service provider networks. And taking that into consideration, I could conclude that the web panel was most likely set up to be exposed to the WAN, and they were probably remotely logging into that and manually changing the settings. Based on that, I did a small experiment. I set up my own PC as if it was the ISP switch, like by uh, copying the IP settings of the ISP switch, which was the default gateway, and then I plugged the router's WAN port to my PC uh, in such a manner that the router thought my PC was the gateway. And then I tried to scan the router with Nmap for any open ports, and I didn't find any, not even that of the web panel, as if there wasn't anything exposed to the WAN. And so even thought I guessed they were remotely managing it via the web panel, I actually had no way to be sure that that was actually what was happening. So how could I figure it out? Well, more sniffing. Uh, so in order to find out what was going on, how they were able to remotely update the router settings, I decided to set up some passive sniffing. the idea was that I was going to place my PC between the ISP switch and the router, and it would transparently forward all the packets going on back and forth. But I soon discovered that achieving this via software is not a really straightforward task. Like it's pretty simple when we wish, say, forward all traffic on a specific TCP port to another device. You can use IP tables rules, maybe a proxy. But the thing is, as I couldn't be sure how they were accessing the router, I wanted to forward all the traffic on all TCP ports, maybe even traffic that was not TCP at all, such as UDP, ICMP packets, and this was very challenging to do via software. And at some point, I started looking at possible hardware solutions. Now, if you're familiar with networking related topics, you might have heard of network hubs and how they are different from switches. Switches forward network packets from one port to the other based on the destination's MAC address. Hubs act more like a dump switch, in a manner that all incoming packets are forwarded to all other ports without any regard for MAC address or not even for anything like. So if you have a device connected to a hub, it receives even packets that were not intended for that. And so as I remember that, I started thinking that I needed a hub. So I could connect the cable coming in from the ISP to one port, the router to another port, my PC to a third one, and then I would be able to passively sniff the conversation from the PC. But there's a problem with that hubs are real-world technology. They're not really used anymore nowadays. They're not easy to find. It's practically impossible to find one for buying. And I did briefly attempt to locate some on Google, but all I got when searching for hubs were actually ads for switches. So I had to start looking for other options, and after a few more searches, this turned up. Well, this is not a hub. This is something that sellers call an Ethernet splitter. And how does it work, you might ask? And the text from the product's description here and the images, it gives us a pretty good hint by saying that it does not support two connections at the same time. And this means you can use it, for instance, to connect two computers to a single Ethernet port on your router or your switch, but you can only use networking on one of those computers at any given time, never both of them simultaneously. And this implies that this Ethernet splitter simply splits the electrical signals coming from the wires of the Ethernet cable to the other ports. It's like the same thing as splicing three network cables together, which you could do at home, but this splitter here seems like a cleaner way to achieve it. And I have no idea actually why there's the demand enough for these things to even exist, but I'm really glad that they do because they were quite convenient. And your first thought might be of using it like this, by connecting the ISP cable into one port, the router to a second port, and the PC that will do the traffic sniffing to a third one. And that's what I had thought of doing too before realizing that this would not work. And the reason that it does not work, like if you ever uh, open up an Ethernet cable, if you ever cut, if you ever try to make your own, you'll know that on the inside they look like something like this. They have uh, several wires, and at least on 10 Mbps and 100 Mbps Ethernet, like not gigabit Ethernet, what happens is this: when you connect the PC to a switch, the TX wires, which are used for data transmissions, are the green wires, and the orange wires are the ones used for the PC to receive data. On the switch side, it's the opposite. The green wires are for receiving, and the orange wires are for sending data. So, in short, the network port has separate pins for transmitting and receiving the data. And while we can dump the packets that, considering we are on PC, we can dump the packets that arrive on the receiving pins, but we normally cannot dump the packets that arrive on the transmitting pins, right? And the problem with that setup I had shown you is that the either the router or the ISP switch would end up uh, transmitting the packets, and they would end up arriving at my PC on the transmitting pins. So I could only sniff one side of the conversation, which is not what you want. We wish to be able to capture network packets being sent from both devices. And my solution was actually to, if you cross over the pins, if you create crossover Ethernet cable, you could get somewhere. Like you. So what I did was this. I used an additional network card on the PC. Actually, it was just an USB to Ethernet adapter that I had laying around, and I set up the cables like this. Here you notice that one of the cables must be a crossover cable, like swapping the transmitting and receiving wires on the connectors at each end, so that packets from both sides of the conversation between the router and the ISP switch will end up on the receiving pins on both of the network cards. And while this is not illustrated here, I also cut the transmitting wires on the cables here that were going to the PC. So the PC could not transmit anything which could interfere with the conversation between the router and the ISP switch. While on Wireshark, you do have to set it up or to sniff packets from both network cards, and things are not always in sync. So with this setup, it's pretty frequent for you to see packets out of order on your dump. But for my purposes, this was enough since I could still make sense of the traffic and understand what was going on between the router and the ISP switch. So now that I could perform passive sniffing on the network traffic, I moved on to the next part of the plan, which was involved a little bit of social engineering. And the idea was to call the ISP support and request a Wi-Fi password change while observing the traffic, so I could see how they were changing the router's configuration. And by doing that, I discovered they were actually accessing the router via its web panel. And the traffic was plain HTTP, so they did not have any encryption, anything like that. It was on port 80. And the problem was that this normally should have been enough for me to simply read the password on the plain text traffic. But that specific router model, its web panel had some JavaScript code that actually sent the password to the router's backend as a hash. And it was not a fixed hash like in the manner which you could simply replay it. It was a dynamic hash. So the web panel of the browser was probably getting or generating some random number via JavaScript and concatenating that with the password, and before sending that to the router, like something like a one-time password, just like what you have on multi-factor authentication. It was probably something like that. The interesting thing here is that this was not defensed by the ISP, right? Uh, if it were another router model, just doing this passive sniffing would have worked. And it didn't because of coincidence that that specific router model that they had did this. But I'm pretty sure that they were not even aware of it. Like, that wasn't the only model they used. So at this point, for my options for obtaining the actual password was trying to find out some weakness related to the hashing algorithm that they used and attempting to somehow obtain the original password from the data I already had. But I think that this would be very time consuming. There wasn't any guarantee that it would give any results because if they had actually implemented the hashing algorithm in a proper way, uh, this would not lead me anywhere probably. If the hash algorithm was properly implemented, if they were using a proper password, and so I ended up deciding that it would be more effective to perform a man-in-the-middle attack. Because since I now knew that they were in fact accessing the router's web panel and which TCP port they were using, I didn't need to do passive sniffing anymore. I could simply use my PC to forward the traffic on that port to the actual router. And as that traffic was plain old HTTP unencrypted, I could modify it in any way I'd like. So the idea was to call the ISP support and ask them to change the Wi-Fi password and once more, but this time I would inject a JavaScript logger to the web panel, which would capture the password directly from the web browser before the password was turned into a hash and submitted to the backend. And this was what my final setup looked like. The cable coming from the ISP switch was connected to my PC, and that in turn was my PC was running Nginx as a proxy to the actual router web panel. And this was achieved by the proxy path directives together with some other rules such as subfilter in order to change the original page and extract the JavaScript logger that I had written, and as well as a routing route to a local Node.js application which serves simply to receive the JavaScript logger data via post and store it while also showing it on the screen so I could watch everything in real time. And so with that, I finally got the password. And it's here's some observations. That password seemed random generated. I could not identify any particular pattern or meaning in it. And from the data I captured by my JavaScript logger, I can notice that the support worker did not type the password directly into the web panel. So like he did not, he probably copied it and pasted it from somewhere. And what I'm guessing is that they might have had access to something like a spreadsheet containing a list of IP address and their respective passwords. But luckily, I had also programmed the logger to capture the data directly from the login form, because if I simply logged in what was being typed on the page, that wouldn't have been enough because it would just have captured like the worker pressing Control V on the page. But yeah, um, I could get the thing from directly from the form. And after I used the password to take a look at the router web panel for myself, I noticed that the WAN access was restricted to a specific IP address from the WAN, which explains why the port didn't show up on the Nmap scans I had mentioned before. It was because the WAN access to a panel was restricted to a specific IP address. And one more thing, in order to completely satisfy my curiosity here, I want to verify if that ISP hadn't been reusing the same password for all the routers they installed for all their customers. So I sent that password I got over to that friend of mine, and I asked him to try to log into the router we had by using the same password, and he did not succeed. So I guess they were at least using a different password for each customer after all. So yeah, they have that going in fact. That's it. This is the actual end of the talk. I hope you have enjoyed it. If so, you might wish to follow me on Twitter. You can message me on Telegram if you have any questions. Maybe if you simply like to talk. There's also my website, which really is just a list of links to my social media profiles, but it's there if you like to visit it. And thank you, everyone. Does everyone have any questions?
Hey, Rodrigo.
Hi
First,
there.
thanks for the talk. It was mind blown. It's super technical. I really like to program, and to be honest, networking for me is the hardest part. Like, I don't understand much beyond fetch. Like, and but it was super great. Thanks. And it's nice because I think our next talk will also be about routers and and things like, and ancient routers. I think you had an almost ancient router to deal with. And well, thanks. Do you want to add anything else before, like, you shared your website and socials, but if you want to say anything before the next talk, we have like 2 minutes here.
No, like, if anyone has any questions, you
okay.
You
stay by the chat
here, or you can, right?
Okay. So yeah, people are saying congrats, and they said it was very interesting in the chat. So if you want to reply them later.
All right, thank you.
Okay, so I think thanks. We can start. I think we can put Fernand if he wants, because hi Fernand.
Hello everybody. Do you hear me?
Yes.
Oh, good.
I hope. And very nice to see. Also, I was talking the previous talk that someone brought up Russian literature, and it's nice to see a historian now, somebody that was a historian in the past, to also talk, because I like this intersection of human and programming, like, and not just staying in the code side. So it's nice to see people bringing that up too.
Yeah.
So,
well,
have a nice have a nice talk, and I'll be here, and I'll come back when you finish, so we can maybe chat a bit and come with questions from the chat.
Okay then. So I'll be sharing my screen here. Let's see. There's a whole bunch of subjects to. So from the beginning. So this router will be about resurrecting ancient routers for fun and necessity. And I'll be turning off my screen because the camera. So this is the thing. We'll be talking about how to resurrect ancient routers because there is this necessity to use network equipment. But those equipments, they're quite expensive, and if you're trying to make gambiarras on them, that can be quite a problem. So this is a little about me. I don't see the slides moving. Right. So this is my personal. This is my there's a delay, right? So this is my personal site. My links to my social networks, PHP for encrypted email. These slides and the videos that I'll be showing here, they are available on this repository on at Codeberg. Those about OpenWRT I haven't uploaded yet because I haven't been able to clean up my personal information because they're attached to devices. So the topics, we'll be talking about a little bit about what are ancient routers, why they're important. And we'll be talking about ASTs, Internet Service Providers, and general purpose computing. We'll be seeing an overview of OpenWRT, the system installation, and a little bit about breaking prevention, how to use the image builder of OpenWRT to customize the firmwares, and how to and some use cases such as mesh points, some enhancements to Lucy, the web interface, how to make USB extension to use the storage for both sharing network storage and to use a system, and finally ad blocking. Then conclusion and questions and answers. So this is all about gambiarras. So this is mostly for educational and academic purposes. This is not intended to be run on production software. We'll take no responsibility if something goes wrong there. So about the routers on themselves, what can define if it's ancient or not? It's basically their age and their hardware specifications. So if you have a single core CPU that's below 500 megahertz, that's a router that's a poor choice nowadays to be using for production. Also, these routers normally they have 4 to 8 megabytes of flash storage. That's a problem because you simply can't fit the system quite well in there. They have 32 to 64 megabytes of RAM. If you have a device that's 4 of storage and 32 of RAM, you can still run some, you can still do some cool stuff in there, but less than that is practically impossible to be doing something. And 8 megabytes and 64 megabytes of RAM. That's borderline. The newer versions of OpenWRT and other systems will work, but it might be unstable. It might be prone to crashes and all that. So these devices, even though they're still functional, they are abandoned by the vendors because they are no longer receiving official firmware updates. Because the kernel Linux is quite the old the drop bear interface program. It's dated. It has known bugs, and that's quite a problem. So that's when comes communities of users who can build custom firmwares, because those firmwares not only they provide a better patch level, they provide more features, and people don't have to tolerate the business models that they propose, that the device should be bought every now and then, instead of getting using most of it but until the life cycle. So this the storage space limitations, this is our first gambiarra here, is by using the USB port to place both the system and to share network storage. So when we have a few megabytes of storage, we can turn it to many gigabytes of storage just by flipping the right switches on the USB port. So if you can use a USB device, we can also use swap memory. But this swap memory, it must be reminded that it's much slower than regular RAM. So all software execution will be kept by this availability of RAM. So there's no, we can avoid, for example, episodes of the memory running out, the OOM out of memory, but there's not much beyond that. Either way, this is such devices. They are cheap, they are easy to find, and if something goes wrong, if you do stupid stuff, and in them, it's not a great loss of money, but it also provides us a cheap laboratory to work to learn more about embedded systems, learn how to configure your network, how to increase security, and so on. And also people who have who are good with solder iron, who can solder serial pins to devices. They can have USB ports placed on them and all that. So that's not my cup of tea. I'm not so good with solder iron than I'm with the keyboard. So I'm more like a software hacker and hardware hackers. That's our good friend Lucas Teske. I still have to send him a router to have a USB port. That will be a fun thing to do, to have a device that has that has low storage, that has a USB port, just a new one. So we see here that that's the map, the network map, the network plan that will be seen here. The device that will be seen the most will be this one that's attached to the ISP device. It's a fairly good device, but it has both AP. It has a radio of 5 gigahertz and 2.4 gigahertz, so it's better to only use one frequency. The the green arrows you see here, these are communications by using mesh networking, and the black arrows, they show the cable and all that. So I'll be showing you guys a video here. Just a moment. Where we see this device. This device will be seeing how it works on how can access it via SSH and then the Lucy interface. So here I configure it to have the web interface to be listening only on local interface, so it won't be accessible using the LAN device, the LAN IP. So here I make this tunnel, and then I bind this local door to the local door of the device. So I'm using a SSH tunnel that allows me to have a HTTP connection that's functional and encrypted without the need to install certificates. So here we'll be seeing. Here we see the model of the software. That's version 19. It's an outdated version, but still functional for this kind of for this kind of device. Here we see that has RAM memory. It has swap memory, and also the system has where it had some 2 megabytes. It has 1.3 gigabytes of space to install. Normally, it would be hosted here on this MTD block 4 that's unmounted. So I simply flipped the system to the USB device. It also has 2 network interfaces. It has a mesh point and also has an access point, a regular access point. That's the purple arrows you saw in the network map just before. And here they are both using same channel and same frequency. That's 2.4 gigahertz. So here we see how to detect if the device is compatible with mesh networking. This particular device, it's also compatible with monitor mode, so it's good to use with Wireshark and some more advanced tools like that. Here we see both radios of 2.4 gigahertz and then the 5 gigahertz frequency. Now we see how many devices it's connected to in the mesh networking, and it shows here that it has the uplink, that's the interface for VPN, and the local area network. Those devices, those mesh devices, they're connected there. Here we see the HTTP server listening on the local door. This is completely arbitrary. I can configure it to be accessible by the outside IP, but I chose not to do it. Just a moment. I lost the other video. Damn. The other video finally. Sorry about that. So here I have to open the address. I have to type the same door that I have typed previously on the SSH tunnel. Here we can see the same info that I showed before. This is the mesh point connected. So here we have the access points and all that. Notice that the Wi-Fi spectrum here around my house, it's quite saturated. It can be complicated. This can influence the performance. So you have to be mindful of that. Now the switch, this particular device, a friend of mine had given it to me. It's not the one network, the one port. Sorry, it wasn't working, and it happened that by simply changing another port to have the uplink, I was able to fix the device. That's something that you cannot do easily with a stock network, a stock firmware device. Here we see the package manager of OpenWRT. It shows we can search for software. We can see if there are any updates, and you can see the installed packages. So Nginx is not installing there. Here we have Nmap. Nmap can also use to scan the network segment. So here we see that there are three other devices connected. So these other devices they were shown on the network map, and we can see also how the mesh network is faring, how the performance in its running. It's at 30 megabits per second. That's a fairly high rate for a device that's with such velocity. So then we have the ad blocker. Most unfortunately, I chose the wrong video that won't be showing how the IP is blocked. But if the ad block is active, it's connected. It's pretty much out of the box. It's working with DNS mask. So whenever all devices that use that as DNS provider, they won't be seeing much ads. This list is configurable, of course, but it worked like that. And finally, VPN. That's in version 19. I wasn't quite able to make it run to make it work correctly. So back to the presentation. Ancient devices can also be they can also use other systems to replace the stock firmware. LibreCMC is basically a free software solution for the OpenWRT. It doesn't accept proprietary drivers, unlike OpenWRT. We can also have Tomato, Gargoyle, DDWRT. That depends mostly on the hardware that's compatible or not. Not all hardware can be turned to a custom firmware. So the good thing is that when we tinker with this kind of devices, all this knowledge, they can be used with newer devices. And it's important that we have people that are interested in this tinkering, because hardware and software, they're too far important to be left on the hands of big tech executives and the guys, the minions on the regulatory agencies. So we must have free, libre, and open source conceived as a rule and deployed by default. There is no technical justification to have these firmwares, these drivers, and all that as closed source. After all, we must think that when you have free hardware, when you have free software, everything about the device, it is known except the password. So this is a safe system. That's a notion that's not invented yesterday. That's something that comes from the times of telegraph and regular mail, paper mail, snail mail, as people call it. So it's something that we should be aware of, because in every computer network, there is someone doing pen testing. Who is doing that on your own home networking? Our good friend Rodrigo has shown his adventures with the ISP, the routers. So these ISP routers, they should be conceived as a consented intruder. They are not supposed to be touching all over the user networks, because it's easy to get infected, because it's outdated devices, and all these devices and all our network, our user data, network data, all flows in and out of those devices. So it's subject to interceptations, to person in the middle attacks, and all that. So these essential services such as DNS, DHCP, and Wi-Fi, they should be controlled by the user and away from this router, from this edge device. So pretty much in an architecture like that, these two devices, they could be the same thing, or one device or two devices, a pfSense, OpenWRT, I don't know. That's up to the user, up to the use cases. But the ISP device, it should be isolated as much as possible, because it's not possible to trust the stock firmware that comes installed on it. And it's not only this one. It's pretty much everything. Cars, they're not the firmware. It's dumb. Medical cameras, whatever. We all know the drill here. So whenever it's not possible to replace the systems, they should be isolated. And one thing that we must keep in mind is that we're talking about a dog with many owners, and we all know that the dogs who have many owners, there's no one to actually feed them. So we have to think, who's responsible for feeding this dog? It's the users. The users can do it because the vendors and the ISPs, they won't allow it, but they won't do it either. So that's a bit of dilemma that we have here. So one thing, just to close this subject, there must be privacy and freedom for users when it comes to hardware and software, and there should be transparency and accountability for hardware vendors and service providers, because that's sensitive data they are dealing with, and they should be more careful when it comes to that. Now, back to the OpenWRT. I'll be talking a little bit about it. The cool thing here is that despite the fact that it can be built from sources, recompiled and all that, but here we'll be using the image builder that's based on on stable versions of OpenWRT. That's because it's easier to handle the package manager. So the hardware here, we have total control of the hardware. So we can enable Wi-Fi mesh if we want. You can use the USB port as we please. You can configure the LEDs and buttons to, for example, to activate the Wi-Fi or deactivate a service or anything like that we are capable of programming. And now we can add new features to the device, such as VPNs, ad blockers, network storage, and all that. The limit here is our imagination. But as I mentioned, those are ancient routers, so the version 19 of OpenWRT is more suitable because it uses Linux kernel of the version 4. Version 5, it's quite hard to accommodate all the needed software. It comes to line of code in the end of the day. So it's not a system that's backed by any big tech company. It's free, open source, and all that. So it's maintained by their own community. So new devices, when you install new system in old devices, the warranty vendor probably is voided already. But you should be always aware that the warranty goes throughout the window, and also there can be hardware failures. But keep in mind that it's always possible to unbrick a device that if there is no hardware failures. So the most common causes of breaking, it's insufficient research and lack of attention. Kids, hear the voice of experience. Do not do this. Do not flash a system on a device if you're sleepy or drunk. It doesn't go well. Because we tend to screw up the partitioning. That's technical error that happens in there. We can access the device throughout some other channel, such as serial, but cannot, the boot is screwed up, so we can't access the network anymore. Sometimes we can access the device, the network, the device via network because it comes bricked by network, by factory. So the vendor sold the device as bricked. There's some histories of that. And finally, there may be errors, physical errors, bad things happen. So there may be some electricity outage. And another piece of experience here, always use good quality cables. Do not use crappy USB cables or network cables, because one bit that does not copy it correctly, things can go wrong. So always do your research when it comes to these devices, because there can be many variations. The name of the device is same, but the version of the hardware is different. It's a different version sold only in China or European Union and all that. You should know the difference between the versions as well. And we also need to be familiar with procedures such as factory reset, that we can wipe out all the configurations that we made before, after the system was installed, to how to activate failsafe mode, and how to use channels, other channels such as JTAG or serial and so on. So finally, we have the image builder. So like I said, it's based on stable releases. We can use OpenWRT and image builder on virtual machines, and besides that, we can use another hardware architectures. The MIPS is highlighted here because it's all the devices that I've been dealing with, they are TP-Link and all use this architecture. But I have some REM devices. It works on OpenWRT works on Raspberries and all that, even though they're Broadcom. Broadcom is problematic because of the drivers, but the problem lies somewhere else. So we manipulate the package manifest, and that allows us to install software in a manner that's more efficient than using the package manager. So the storage space, the initial storage space, it's better put to use, so we can squeeze more software in there than using OPKJ. And these devices with the 4 megabytes of storage, you should be aware that some software has to be explicitly removed, such as point-to-point protocols, IPv6. We can make a flavor that has no IPv4, but that's for those crazy loons that who knows IPv6 already. I'm not one of them. So we can also remove DNS mask or OPKJ, and in order to free space for other software. We can have functional USB storage working if we add merely 3 new packages. I'll be showing an example of that in a moment. And one thing about the libraries, since it's embedded software, it may be hard to uninstall and install software. Then that might be more difficult to do than flashing new. So make sure that these libraries that we use as SSL libraries, they are aligned, that we are using the same version, because OpenWRT has using WolfSSL as default, and if you are using OpenVPN, that will provide conflict because there is no other version of OpenVPN that doesn't use OpenSSL. So there may be problems later on. And it's also possible to modify files in the image, so you can make the image comes ready to be using, for example, the segment an arbitrary network segment instead of using the defaults. And finally, if the build execution was successful, it will generate a sysupgrade file that should be used to install if OpenWRT is already installed, and a factory image that should be used when upgrading from stock. You should be always aware of which image is being installed, otherwise the device might end up bricked. So back to another video. I'll be showing you how to a little bit how to use the builder. So here we have the image builder. It's downloaded from the OpenWRT site. We should extract in a Linux machine that uses 64 bits, that has some software to be installed previously, mostly compilers and Git and things like that. So here I'm going to be creating a symbolic link to another folder, so it can be used, so I can manipulate the files variable when building it. So here I can choose from I can get a configuration file from any of these folders that's available from here. I'll be showing how this ends up on the command line. Here we have we type make info, so we can see which devices they are compatible with this particular version. There are a whole bunch of devices. Notice that these devices they're not found to be downloaded on OpenWRT sites. Even though the system supports them, they have to be built manually, as we'll be seeing here. So here we choose one of these profiles. Here I'll be using this particular device. That's a small device that has a very low consumption of electricity, and also has a USB port. So I state the profile, then I say from where it's getting the files, these configuration files, and finally I give them the package list. Notice here that the package list is quite extensive. it's not all the packages that are installed there. They are listed here. Those are the full list. There are some more of them. They're pulled by automatically as dependencies. And see here that I included the last closer to the end. I included iPerf, so I can use so I can test performance. BRNet filter, so I can use mesh networking without switch. And here we see these three packages that I mentioned previously. So this device, it's a very slow, it's 4 megabytes storage, but it will come USB ready. It's just a matter of configuring, and so I can use the device automatically. This is the WPAD. It's the software that's used to manage the Wi-Fi. Here we are using the mini version, but if you want to use mesh networking, we should use either both SSL or OpenSSL. Both of them, they'll give you all mesh network functionalities. It's just a matter of adding it there, adding it here. This other software, swconfig and dnsmask, they were removed from the. They're removed, and notice here that I placed the dash before them, so they are explicitly removed, because if I don't do that, they will be installed. They will be pulled as part of the default. Here I'm explicitly saying that I don't want them to be installed, not them, and not and also the IPv6 stack and the PPP, the point-to-point protocol, and other things related to it. So what happened here? Here I got some error that was on purpose, that I typed wrong, because then to show people that command line is not going to bite you. It's just a matter of reading the screen, and the error will normally, notice the emphasis here on normally it's going to be there. So here it was merely a typo. I changed from underscore from dash to underscore, and now it worked. So I'll skip here to I won't be showing the compilation. If everything went correctly, it will come to this, and it will be showing how to show that has no errors here. If there is something that goes wrong, it will say here. Normally, it's because we add too many packages to a given image, and then it's then the firmware image won't be able to handle it. And here we see since the compilation went correctly, we have these three files here listed on the left. This is the images that they mean that all went well. And we have the package manifest. If you are curious to see which package, which are the full list of packages that were installed, it's listed in there. So driving to a conclusion, we should think of, we are talking about ancient routers, but we should be thinking about the future. So what future do we have? We must have customized system. We should have self-hosting, that's software and services that are hosted by ourselves instead of handing them to big tech companies. We must have interoperability between services and devices and system, and decentralized networks, and all that underscored with hardware that's both free, libre, and open source. After all, as the feminists say, my body, my rules. For the online version of that would be my device, my data, my rules. There should be privacy for the users, and transparency and accountability for the vendors. And what should be improved in that? We should have drivers and microcodes that are libre, even if by reverse engineering it's only the business justifications to have that. After all, as Linus Torvalds says, show me the code, and if you don't show me the code, you can be trusted. We should improve the documentation because there's a whole bunch of devices that haven't been documented yet, and also besides documentations, there should be better tooling and better graphic interface. Since this is something that done by techies for techies, we should be worried about developer experience, developer interfaces. It's not everybody who feels comfortable with command line, and there should be more graphical anyways. Also, when it comes to electronic device, there should be a right to repair. I don't accept for a second the justifications of Apple and other vendors that there should be no right for the users to repair their hardware or change their software. I don't accept the justification. Just buy your mom an iPhone. No, I don't buy it. And there should be much more recycling, and the supply chain should be much more sustainable. After all, you can defend business plans and business models that are not ecologically sustainable, but you can convince me that's eco-friendly, and you can try all the greenwash you want. You have to pick one. Either you are sustainable or you are driven by programmed obsolescence. And finally, there should be more communities. The communities of users, they should be developed. The people should feel welcome in such communities. It doesn't matter race or gender or ethnicity or nationality. There should be, or even knowledge. Not everybody was born knowing it all. So we should have to have that in mind. That we should be spreading more knowledge instead of worrying about ego. And this device, we're talking about ancient devices, but the evolution of those devices that will be multi-core CPUs, LAN gigabit, and Wi-Fi, more powerful Wi-Fi, and USB 3. So these are distant hardware parts, and they will be around a long time because as of 2022, we are having supply shortages of processors, of boards, and all that. So we should be valuing and extracting more of the hardware that have available, and we don't need to take it for granted. So that's what I had to be presenting. Thank you all for your time and attention. I think I didn't blow up the time since I didn't hear anything, so I'll be opening for questions and answers. So that's about it. And also open the camera as well.
Hey, Fernão, thanks a lot for the great talk.
Thank you guys for the opportunity. I hope you have enjoyed as much as I liked giving it.
Yeah, we have some time for questions. We had some people chatting about in the middle of the talk. I don't know if anyone of them want to throw a question. But I like to say I really like the ideals of decentralizations that you put forward. Like we should self-host things and have access to the source, and that's it. I fully agree with your ideals there.
Right, questions.
Yeah, we have some time for that. We have like 10 minutes to the next one. So
10 minutes? Damn.
Yeah.
Thanks, Camilo.
No,
thanks for.
Oh, say.
I'd like to say thanks to Camilo because he heard the first version of it. I think the second version as well, even though he didn't participate in the talk afterwards. But thanks for your help. Your feedback was quite important.
Nice. And but it's fine. Like if we don't have questions, too, you can answer them later in the chat, and we can maybe see the next talk and start it. So.
I can. It really came earlier than I thought. I can do some live demo if you guys want. There was a video that I didn't show. I wasn't quite aware of the time because the clock and my notebook have been some problems.
It's fine. You have 10 minutes easily to do it. So
10 minutes. So right, I'll be showing. Let's share the screen again. Right. So this is the OpenWRT site. Most of it's in English. I've had some contributions to translate into Portuguese, but we need more volunteers to translate job for everything. Here we can do initial search of for devices that are supported. Here we see all these devices. Some of them, they will appear on the downloads, but most of them will not. The 19 version, it has gone out of the initial page, so it might be hard for people to fish them. I put the link on the end of the presentation. It's shown on the address there. And here we see the generic. It's for devices that are the 8 megabytes of RAM of storage, and the tiny, it's for 4 megabytes. Notice that here they didn't produce much the full image, so we need to use the image builder to squeeze other hardware in there. So this is the package we download, and that's the manifest that's contained in the full images. So that's not much to it. I intend to release some videos where I show the whole process. That's not a 45 minutes. So people who want to learn more, they can get stuff from there. And here, I'll be. I thought I saw some questions, some comments in the. So this one here, it's the device that I use in presentation. It's on the Lucy interface. The ad blocker, we can see it working here. Google. So it doesn't know the address Google @google.com, but it knows the address Google. So it won't resolve that. That's the most fun part of ad blockers, because if you control the DNS, there is no way that the external actors, be the service provider or even Google itself, that will tell us which ads we are supposed to be seeing. So, and one last thing, I'll share the screen just so I can show. For people who are not Brazilian native, Portuguese native speakers, so this is a concept of gambiarra, because here we have two USB ports connected to the outlet. We have a USB modem. There is no GMS chip in here, but there is an SD card, so that's how the device is. The device uses extra routes, and here we have serial access to the device. I had a friend of mine solder iron the serial pins to the serial port, so I can use this converter. Then USB connected to my computer, and we'll be seeing a little bit of it. So Marco, please let me know when my time is done, so because that's the.
Oh, it's fine. You have 5 minutes, but if you wanna end, it's up to you.
Okay, just one quick thing here. So use a software called. Can you guys see the? Let me increase the size. So here we need to use sudo because it's a root process, and then it might seem that there's not much going on here, but here's the. I'm gonna reboot the device so you can see. that's the thing that is not visible when you're using from the network, because by this time the network connection will be terminated, and then we see the device running. Here we see pretty much like any Linux distribution, but the only difference is that something for embedded devices. And here we see starting to load stuff, and we see that it detected the USB port, and by now we have already a console port. But notice that things will be spitting on the screen, because that's serial entrance. That's something that we are not allowed to see comes to when by using network. So when it happens that you have a brick, we think the device is bricked because it's not accessible from the network anymore. Here, you see that took quite some time until it loaded everything, and we can see that it loaded everything correctly, because we can see the USB device here, and this is the original the original place where the system is hosted. So when I mount this USB as an overlay, then it will become the system in itself. And one last thing, just since you have time. This is the command that's used to perform a factory reset. When you use a factory reset, we can either press the button on one of the buttons on the outside of the router, or we can do this by on channel. So it says that we'll remove all settings that have been changed before after it has been installed, and an installed package. So yes, I'm sure. That's another thing that won't be able to see throughout the network, and it's only be seen on the inside here. It takes a few seconds. Oh yeah, of course, that it's clean. So, and now I should be rebooting as well. Sorry, guys. The reboot you have seen already. So yeah, that's pretty much it. So if any more questions that you guys have, please feel free to.
I didn't get something from the chat, but something you said I'd like to double down on. You said it's missing translations or something like that, and I always see that there's much space for translation and copywriting and documentation. And in open source, I see that the greatest barrier is that most people that know how to do this, they don't know how, for example, how to interact with GitHub. So if you're listening to this present conference and you have friends that knows how to do this, like knows how to translate or how to write text, and maybe it's looking for a job or do something to do as a hobby, this is a really nice place to start, because you can help projects that need translations, and will help tons of other people with other needs. And it also makes you like a curriculum for entering other places, like finding a tech job as a writer. So I think this is a huge field that if you have friends that you can teach how to use GitHub so they can go and do this, you'll be doing, I think, a really nice public good. So that would be my double down.
Indeed, every project. I'm an Arch Linux user, and the Brazilian community is quite strong. The translations, both level and quantity, it's all par with the English one. But OpenLaborT is not this mature. It's a shame, because there was much material that was lost when they had problems with their data center or something like that a few years back. And many things many previous knowledge from the OpenLaborT, it was lost. Thing is, they were mostly outdated tutorials and all that. But even so, it was nice to see that there was many pages in Portuguese and many pages in Spanish, many pages in Chinese, Russian, and all that's not on something that's concentrated in English. But English, like it or not, it's lingua franca. So we must know at least how to read it.
Yeah, and I think given enough time, all these really great infrastructure projects, they will have documentation and translations. Just we have to give it time to people to adhere it to. So
Eventually.
yeah, eventually in the future. Well, thanks a lot, Fernando. It was a great talk. If anyone,
Thank you guys.
Anything in the chat, but that's it. Thanks. And
Okay,
well, thank you. Our next talk will be from Bruno, and he will talk about PHP and serverless PHP. I think it will be a fun one, and I think we can start this one. I don't think he'll answer now. Maybe answer to answer questions, but I think we can start his talk then.
Okay, let me just set this to presenter view. Perfect. Yes, and full screen. Hi guys. First of all, nice to meet you all, and thank you very much for taking the time to be part of today of this conference. And today we'll be talking about building a serverless PHP Laravel application using Laravel Vapor. And the buzzword of maybe 2 years ago or a year and a half ago, serverless. These are the contents that we're going to go through, explaining a little bit of traditional systems architecture. It's going to be a bit boring for the more senior guys, but it is important to talk a little bit about it to the more junior guys or mid-levels that are not aware how things were structured in the past. And we're going to go through some of the contents that AWS offers for you to glue all of this together and use serverless in the end. And then in the end, of course, not everything is a silver bullet. So we're going to talk a little bit about advantages and disadvantages of a serverless architecture. First of all, my name is Bruno. I'm a wannabe front-end developer. I work at Codoto.com and I am originally from Brazil. As I said, I work at Codoto, and basically what we do is to make it easy for you to organize IT meetups in your city or in your region. I would highly advise you to check it out. Currently, we are more operating in Zagreb, but we have plans of expanding a little bit to Lisbon in the next year or so. So first of all, let's talk a little bit about traditional system architectures, how web systems were architected before. Well, everything was dumped into a single server. So you would have your web application, database, and maybe even cache, everything in the same server. And of course, user 1, 2, 3, and user n would make the request directly to this web application. Well, then the second one that started to appear because of the problems that it brought to the first one, we're going to talk a little bit about later on. It was we separated these servers now, or these applications. So the first one would have a web application and a database in a completely different server, and the users would make a request to our web application, and then the web application would interact to the database. Well, things got a little bit more complicated, and it was needed to break even more the application. So we are entering in the realm of you have the breakup of the front end, the back end, and database. So right now we have a front end app, and then we would have in another server, or even in the same server, a REST API, a GraphQL, for example, with your web application. And then this REST API or GraphQL would talk directly to your database. And the several users that would make the request to the front-end application, and then the front-end web application would do the rest. Well, there are many other stories here that we could talk about, microservices and many other more, but right now for this presentation, it's not really that important. So what are the problems with this traditional systems architecture? And we're going to be talking a little bit about scaling, over-provision, and many more. So let's go back to our last architecture that we saw. where everybody would make a request to the front-end application. Front-end application would talk to your REST API or your GraphQL application, and the GraphQL or the REST API would talk to the database. And let's focus a little bit more here on this REST API GraphQL. There are several problems here that we can see. We can over provision this, so you can rent a server with 5 gigabytes of RAM, but in the end of the day, you're just using 1 gigabyte of RAM. This is a single point of failure. If this goes down, you will have problems. Whenever you over provision your servers, you're gonna end up paying more than what you should. You have to manage the server, of course. It will be harder to scale. You will need a competent team to make sure that you do not break things while scaling. You need to pay for DevOps, of course, and the server may be physically located away from the users. So the server might be in the United States. A guy from Australia make a request to your server. It's going to take 2 seconds, a second and a half. So what is serverless? How do we turn how do we turn server management into someone else's problem? Well, the definition is serverless is a cloud-native development model that allows developers to build and run applications without having to manage servers. There are still servers involved, but the whole complexity is abstracted away from the developer. And a cloud provider, in this case, we're going to be talking about AWS, takes care of the provisioning, maintaining, and scaling the server infrastructure for you. Developers only need to worry about developing their application. And in the architecture, very simplified, it is this. Users make a request to a single endpoint, and then under that, you're going to have a bunch of Docker containers that are going to be spawned as soon as a request is received. There are several companies that uses this architecture, such as Netflix, Coca-Cola, and so on, and using in production as well. So what is function as a service? How we pay only for what we use? Well, FaaS, or function as a service, it's an event-driven computing execution model where developers write logic that is deployed in containers and fully managed by the platform, and then executed on demand. What does this mean? You write your application, you write your code, you ship it somewhere, usually can be in a Docker container or some other formats, and as soon as a request is made, a function is going to be evoked, and you're literally going to pay only for the time that function ran. So no more over provisioning your servers. So to talk about a little bit how we glue everything together, or how we build this serverless application, it is important to understand some of the services that AWS offers. And we're not going to be talking too deeply about them. We're just going to talk what they do in general. So the first one is Amazon RDS. It's basically a collection of services that make it simple to set up, create, scale, and databases in the cloud. You can choose several popular engines as Amazon, Aurora, MySQL, and Postgres, and so on and so on. The second one is for us to manage our queues. We have Amazon Simple Queue Services, which basically, as it says, is a fully managed message queuing service that enables you to decouple and scale microservices, distributed services, and serverless applications as well. So Amazon completely takes out that complexity that usually we would have to manage our own queues. The third one is Amazon S3. It's basically, you can think of as your file system. It's not exactly the same, but if it helps to make some sense into it. The next one, it would be Amazon Simple Email Service. It's cost-effective, super freaking cheap to use, and offers a very basic service, but it does it really, really good. Amazon API Gateway as well. So as it says, a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at scale. So this is going to be the entry point for our application. Someone makes a request to our website, arcodoto.com, for example. The first line that it's going to actually see is this Amazon API Gateway, and from this service, we're going to request, we're going to route the request to the appropriate service. And the most important for us and the serverless ones, it's lambdas, and in this case, implementing function as a service. By definition, from Amazon, AWS Lambdas, it's a serverless, event-driven computing service that lets you run code for virtually any type of application or a backend service without provisioning or managing your servers. You can train Lambdas from over 200 AWS services and software as a service, of course, and only pay for what you use, this being the most important one. So what are some of the Amazon Lambdas use cases that we can think of? Well, the first one is as soon as a photography is taken, for example, you upload this photography to your Amazon S3 bucket, and then a Lambda is triggered, and Lambda can run some code that is going to resize this picture into web, mobiles, and tablet sizes. Another one, more to the IoT guys, it's, for example, tractor sensors that send data to Amazon Kinesis, and it captures the stream. An AWS Lambda runs the code, and an order is automatically placed for replacement parts, for example, if something is going wrong with the tractor. Another one is user post a status update, for example. It went to Amazon API Gateway, AWS Lambda runs this, and create basically trends that can be sent to your user friends and update their notifications as well. So it is important to see how handling HTTP requests in Laravel happens. So it's very simple. For the junior guys, when you make an HTTP request, you send a request, you receive a response. A lot of things happen in the middle, but not important for us. And the only code that we're actually going to see today is this one. This is how Laravel handles your HTTP requests. You send a request, a lot of things happen in the middle. Skeletons of services are created, and then in the end, a response is sent back to the client. So instead of this, where we would have a single server, where we have several users making requests to it, we would have, or this, as we said before, we would have this. Every users make a request to your endpoint. In this case, it would be a Lambda. The code that runs in the AWS Lambda is your responsibility as a developer. Everything that happens below that, the server management, machine patching, and all the difficulties of managing servers are the responsibilities of Amazon. And how does all of this work? You would think that you would have to set up everything by yourself. Luckily, we have a service called Laravel Vapor. This is not being sponsored, by the way. So how do we glue all of these services together? Well, Laravel Vapor is a serverless deployment platform for Laravel and powered by AWS. The main things about it is that it provides you on-demand, auto-scaling, and zero maintenance. No more you having to waste a lot of your time trying to understand what is wrong with the servers. So just to give an example, what would look like a high-level overview of Codoto, which is using Laravel Vapor to deploy our changes and to run our whole backend infrastructure? Well, a user make a request. As soon as you make a request, it goes to our Amazon API Gateway. This Amazon API Gateway routes this request to an Amazon Lambda, as we can think here, kind of like a web server. An Amazon ECS, the container registries from Amazon service, it spun up a new container for us, and this container is going to run our code, and this code is going to interact with us, send an email, for example, or create or send something to the queue. And the Amazon Lambda, for example, is going to talk directly to the SQL proxy that is going to handle the connections that we have, and it's going to talk to Amazon RDS. And for the crons and consoles commands that we actually have running on the background, we have another AWS Lambda running as well. And it makes it much easier for everything to run smoothly. So you must be thinking, right? It must take a lot of time to configure all of this. And, well, Yum is the response to this. It's super simple to configure all of this. For us in Laravel, this is our configuration file. We just have a Yum that we set up the environments that we want. In this case, we have one called production and another one called staging. And we can set up all our configurations. What is the domain of our project, the memory that we need for each AWS Lambda, the storage, if we would like to have an S3 storage, a database proxy, and so on and so on. So it is important to talk a little bit how serverless can help early stage companies. And the most important part is to cut costs. Currently in Codoto right now, I think that we are around $80 to $100 per month. And if we would opt into a server architecture, would probably be paying like double what we're paying right now. So what are the 4 main points for me personally, how servers help us maintain a lower cost? No DevOps. We do not need to have a DevOps guy. My understanding of servers are not the best one, and I'm sure there are hundreds of people that are much more knowledgeable than me, and we do not have to pay them to do this. No time management. So the servers, I do not need to manage servers. We save a lot of time, which we can basically reuse this time into developing the application itself. Affordable pricing. Currently for the Lambdas, we're spending around $5 a month. What's costing more is database and other things. The scaling is much easier, so we do not need to lose hours trying to understand how we're going to scale this. And of course, we do not need to take into account the high traffic times in Codoto. Usually meetups happen between 6 to 8. So during that time, we need to have more powerful servers. But in this case that we use serverless, we do not have to worry about those. AWS scales for us automatically. So what are the advantages of serverless architecture? Well, the first one, as we said before, no server management. You do not need to spend time on it. Reduce costs. You pay literally for what you use. There's no reason here to over-provision things and you end up paying for more than what you're using. It is scalable as fuck. You can scale your infrastructure to thousands of servers in seconds. And the code closer to the end user. AWS has several endpoints around the world and several data centers as well. So you can take advantage of deploying the code closer to your main users, or even deploy to several locations. So if a guy make a request on the United States, he's probably going to get a server in the United States instead of getting the one in Europe. And as everything, it's not a silver bullet. What are the disadvantages of a serverless architecture? Well, the first one is testing and debugging. It becomes harder and you need to be more careful how you develop your application. If you do find a bug because you have several services running together, it is a bit harder to actually debug your application and testing as well. You cannot have long running process. Amazon Lambda allows only a maximum of 15 minutes running time. So if you need to do something that is more than 15 minutes, you will need to find a different approach to this problem. The performance may be affected. In this case, cold starts. Laravel Vapor solves this problem by allowing you to constantly make requests to your application every 30 seconds, every 50 seconds, so that whenever a real user makes a request, Amazon Lambda already has a container very close to running, and you're not affected by cold starts. And the last one, and super important, especially for early companies, it's vendor lock-in. So if you develop your whole application around AWS, there's no standard between all of the different cloud providers. If you would like to switch from your AWS Lambdas into a Google platform, for example, you can't. It's going to be very hard for you, and it's going to be very costly as well. Thank you very much. I really appreciate the time. And if we have any questions, feel free to ask them. Thank you.
So, hi. Bruno is not with us now, but he put the email there on the end of the presentation. If you can put the email now in the chat too, so if anyone has a question, they can send to his email so he can answer later. And we will now we will have Lucas Teske talk, and he's right here. He's gonna talk about reverse engineering satellites. Hi, Teske.
Hi all. Just a second, let me just fix something here. I forgot that my camera likes to turn off just randomly, so I'm making a workaround so it doesn't turn off in the middle of the talk.
I was gonna say you have okay. Well, we have Teske's talk now. Hey, now he's back.
Okay.
I think your camera has a bit of delay. Do you want to re-enter the room to see if it fixes?
Sure. Let me try. Okay.
Yes. Now it's perfect. Thanks.
No, it's perfect. I saw this with your audio, like I think in Veloso's talk. I'm not sure why. Maybe it's a restream issue.
Yeah. Well, thanks again for being here for the talk. I'll come back later so we can chat and ask questions.
Sure.
So and have a great one then. You can take the stage.
Okay, thank you. Hi everyone, how are you? Yeah, Gambiarra in live. I'm watching the chat, so you can ask questions. I will try to answer as they appear. But there will be some time in the end of the talk, so you can ask questions and other places that you can ask questions. So let me share the screen here. Just a second. Okay. Okay, so now we have the screen. So hi everyone. I'm talking about satellite communications reverse engineering. I mean, this topic is very wide, so the talk will be more or less an incentive, so you guys can start playing with it. So because every time I try to give a presentation about reverse engineering satellite communications, or it takes too much time, or no one focus in that because it's a very dense subject. So it's not easy to get a presentation and then just understand everything. So the idea here will be making an incentive and give you some directions so you can start by yourself. Okay, so let's start about me. I'm Lucas Teske, and the social networks you can find me as a RacerXDL, Tasker, Cybernetic Lover, or anything else. I usually like programming. Games, fire, lightning, basically anything related to science. I'm there. I went to university twice for the University of São Paulo. I make 2 years of each, but I haven't finished it. I made systems of information with sort of computer science, and I made physics as well. Okay, both at the University of São Paulo. I currently live in São Paulo, in Brazil, and I work for Pride Security as a hardware security consultant. Okay, so I do several other stuff besides hardware in Pride Security, but nowadays I'm doing hardware stuff. So let's start first by the motivations. Okay. So what was my motivations to start that? And basically everything from the hardware to the software in telecommunication systems are basically always follows the same direction. There are some differences between like a cheap remote control to like the Starlink or something like that, but the fundamentals are the same. I mean, you have to modulate a radio signal to transmit data, and in the other side, you need to receive it. Um, Even for the modulations that you use, for the encodings, for the error correction, and things like that, it's more or less the same for mostly of of the radio frequency stuff. The space telecommunication has like a common base specification, so they usually use like CCSDS or uh, something close to CCSDS, which is a specification on how to do space telemetry. So that makes easier to reverse engineer because you know it's more or less the CCSDS and maybe some stuff change it. And usually when they change, there is a technical reason. It's not like just an obfuscation or something like that. So if it's a technical reason, you can also get to the same conclusion and know what the difference is. There is not much about the digital signal processing online. I mean, nowadays there are more. When I started, there wasn't much, especially about satellites. The people that knew how to do kept for them. Um, so for me, at least, that's a motivation to create new content where there isn't. There is also cheap SDRs, software-defined radios. We will talk about that later, but there are several of them. You know, you have like the RTR SDR, which is the most common one. You have the Lime SDR. You have the Hacker Ref. You have the Blader Ref. You have several other radios that you can use for that. And the image from weather satellites, which is the focus here, it showed the beauty of our planet. I mean, it's hard to describe how was the feel when I first received a satellite image, and it's fun. I mean, it's fun knowing that something in orbit of Earth is transmitting something I'm receiving at my house, decoding and getting all the data. I mean, at least for me, it's really fun to do that. So let's start with software-defined radio. What is a software-defined radio? I mean, the name is pretty direct, right? It's a radio that's defined by software, but how can you define a radio by software? And basically, this is a software-defined radio. Don't get scared. It's not that complicated. It looks like, but it's not. So this is the schematics for the RTL SDR. Okay, so you have two ports, which mainly all the SDRs have, which is the tuner, which is the same tuner that your TV has for like broadcast or something like that. And you have like demodulator or a fancy ADC, which is analog to digital converter. Okay. The tuner part, what it does, it gets like a signal that, for example, your TV channel 4, I think it's like 400 megahertz. But the actual channel data, it's only from like 398 megahertz to 401. Okay, so you have like 3 or 4 megahertz of actual channel data. But if you are gonna use like a digital to analog to digital converter, you would need to receive like 400 megahertz, right? Which is a very expensive analog to digital converter. So what the tuner does, it does like a very simple operation that gets like this signal at 400 megahertz, which spans from like 399 to 401 and moves to the 0 hertz or for like the 2 megahertz, because then your signal is from 0 to 2 megahertz and not 399 to 401. And that's better, because then I don't need an analog to digital converter that runs like 400 megahertz. I just need something like that runs like 4 or 5 megahertz, which is way cheaper. So the only thing that tuner does is just shift the spectrum around. Okay, so just imagine that it moves the frequency, the signal from one frequency to another frequency, and it does that by using a mixer. Okay, so on the left side you have like this small square which is saying Rafael R820 T2 tuner, which is the tuner for the RTL SDR, and it can shift anything from 24 megahertz to 1.7 gigahertz. Okay, I will not go into details. It has some filters, some amplifiers and things like that, because it's required. Every process in the signal is lossy, so it needs to recover for that. Then after that, you just like put in a normal ADC. For example, I think some of them that are watching now already played with like an Arduino or anything like that, which has an ADC, which is an analog to digital converter. It's basically the same, but it's usually works at a higher frequency. Okay, and what the RTL SDR have is a 28.8 megahertz ADC. So it basically can read like from 0 to 28 megahertz, and it has some processing inside, so it generates a complex signal. That's a mathematical representation of the signal, which helps a lot when you are decoding stuff. And after it creates this representation as a complex number, it just sends to the computer. So basically, the job of the RTR SDR dongle is done here. Everything else is done on the computer. Like you have the whole spectrum, the tuner is the magnifying glass. Yes, pretty much like that. So you just like put a magnifying glass in the position you want to check, and you are blind to everything else and just see what is the region of interest. So this is a simple SDR, but we have another SDRs. So let's talk about what I consider cheap SDRs. I mean, they're not really cheap, especially if you live in Brazil. Everything is expensive here. So, but I mean, when I mean cheap, it's because a long time ago it was like to get an SDR, it was like I think $20,000 or something like that. So that's expensive. That's not something everyone can buy, not even with right planning. So the SDRs here, even if you live in Brazil, which is can get really expensive here, with some planning you can buy one. Okay. So we have the RTR SDR, which I mentioned earlier. There are several generations of it. Basically, it all started with a TV dongle. Someone discovered that you can grab the direct samples from it. You can just ignore the TV decoder on side and get everything raw. Because this TV dongle also has an FM radio decoder. But the guy that was reverse engineering how the FM decoder works discovered that the FM decoder doesn't run in the dongle but runs on the PC, because FM radio is pretty cheap to decode in software, so it's cheaper than creating a hardware for that. So for FM, it just sends everything to the PC, and then the PC can handle that. So there are several iterations of that. It was improved for SDR operation. So you have like the Gen 6 with ltrsdr.com, which has a lot of improvements for SDR usage. And as I said, it works from 24 megahertz to 1.7 gigahertz. It has a 8-bit ADC. So basically, each sample has 8 bits, and it can do 3.2 million samples per second. So it basically, that means since it's a 3.2 millisamples IQ, which is a complex number, that means you can basically see 3.2 megahertz of spectrum. So remember when I said you don't need like for a TV channel, you don't need 400 megahertz. You need like 1 megahertz or 2 megahertz. So if you shift enough, this SDR works for that. You have, I think, the most known of the SDRs, mostly because it was the first open source, which is the HackerRef from Great Scott Gadgets. It's pretty old nowadays, but it was the first open source. This is open hardware. You have access to everything. You have firmwares, you have softwares. This also transmits, which is nice. It works on a very wide spectrum. Here I say 1 megahertz to 6 gigahertz, but you can actually go down to like 100 kilohertz or something like that. It has an 8-bit ADC, so it can receive samples as 8 bits, and it can transmit as 10 bits. And also can do 20 megasamples IQ, which means 20 megahertz of usable spectrum. This is the old king of the SDRs. Even nowadays, which is pretty old, I mean, the HackerRef probably was done like, I think, 15 or 20 years ago. I think it's 15 years or something. It's pretty usage nowadays. And you can get an AliExpress, you can get everything, everywhere. So, I mean, this is one of the kings. Yeah, your LTR is Realtek. It's a Realtek TV dongle. So, I mean, Realtek does a lot of stuff for network stuff. It does like the network cards, which we all know. It does like radio stuff, which, for example, is the RTR SDR. But yeah, it's Realtek. There is Lime SDR, which is I would say it's the spiritual successor of the HackerRef. HackerRef has some advantages for some stuff. Lime SDR has from other stuff, but Lime SDR is also everything open source. You have all the firmwares, all the softwares. The chip itself, which is the transceiver, which is the LMS 7002, it has a pretty detailed datasheet. So, I mean, Lime SDR, they are amazing because they really supported the community. And I mean, this board was made for making a cellular station, a mobile phone. This actually was made for that. But you see, it works from 10 megahertz to 3.5 gigahertz. And it's a full duplex transceiver. So you can transmit and receive at the same time. And I can't thank them enough because they really supported all my projects, like giving me hardware to test, to improve and everything. So they are not only, the Great Scott Gadget also helped a lot of the community, but when I went to the SDR world, the HackerRef was already there. And Lime SDR came afterwards. So it was like an exchange. I helped them with creating softwares. They have helped me providing hardware and everything like that. So it's a full duplex transceiver, so you can transmit and receive. It has a 12-bit ADC and DAC, so the resolution of the samples are higher than the HackerRef. It can do 61.44 megasamples IQ. This weird number is because this is the sample rate usually used for mobile networks. The actual sample rate of the LMS chip is actually higher. I think as I recall, it can reach like 200 megasamples per second or even more. But here we have a limitation of the USB port. Okay, so 61.44 is basically the maximum a USB 3.0 can handle. So they have another version, which is a PCI Express version that can go higher. But I mean, the most common one is the USB, and that's why you are limited at. But being the hardware being faster than that means you can actually get more than 12 bits of resolution because of some mathematical tricks. And you have 2 transmit channels and 2 receive channels. So it's not only a full duplex, but it's also a MIMO transceiver, which means you can transmit 2 distinct signals and receive 2 distinct signals. Yeah, 61.44 megasamples is really a lot. I mean, even if the USB 3.0 can handle that, not every computer can handle that. That's something people in the early days of the Lime SDR complained that they had defective Lime SDRs because they couldn't reach the 61.44 megasamples. But the problem was their PCs, because the USB stack runs on CPU. So for receiving that, you load the CPU. Just imagine you are receiving 61.44 mega samples. Each sample has 12 bits, which you can say that's like about 90 megabytes per second, which is pretty much, and you are not stopping sending, you are like using bulk transfers because it's continuous transfer. So the USB doesn't have any time to like change to other device or anything like that. So it's pretty heavy. I mean, it's not every machine that can run 61.44 mega samples. Yeah, I mean, the price is a lot, but not that much. I mean, it costs like $300, which is more accessible than like a USRP or something like that. So, okay. Let's talk about signals to receive. So I showed the SDRs. For all the signals I'm showing here, you can use the cheapest one, which is the RTR SDR, which you can buy for like, I think $30 or 30 something euros, which is the cheapest one. But you can also, if you want, get the most expensive one, so you can transmit or make other experiments. You can also do that with any of them. Basically, any SDR in the market can receive all the signals I am commenting here. So the first one is the NOAA and Prime APT signal. These satellites are phased out already. I mean, they are deprecated for... I mean, they probably deprecated the APT signal 20 years ago, but the satellites are... Some of them are still alive, so you can still receive them. We don't know how much time they still have, but you can still receive that. And this is simple because you don't actually need an SDR, you just need a VHF radio. And here are some gambiarras I did. So I usually don't talk gambiarras, which is a Brazilian slang for like that's some of the words that you can't translate to English, but it's like a technical workaround. I prefer talking about that. So you can see I have on the left side like a KFH antenna, which was the first one I did, which is, you can see it's PVC pipes and in cable. In the right side, I have like a antenna I did with 2 copper pipes and a lunch box with my SDR and my computer on that. And it works, you know. It's pretty easy to receive that because it's VHF. You don't need amplifiers, you don't need anything. You just basically connect the antenna directly to the radio and it works. Okay. And you receive some signal like that. Okay, so this is the image. It's analog, it's not digital. So it has noises, but I mean, this is Brazil. You can see the coastal shape. If you're not from Brazil, it's probably not very easy to recognize. But if you are from Brazil, you'll probably recognize the Brazilian coast on the right side. And this is the signal. It's FM. So if you have a FM radio that can reach 127 megahertz, you can hear the satellite passing. You can even see the Doppler and things like that. And there is the, what I would say, the holy grail of the satellite receiving, the GUIs satellite. If you are in Europe, you can receive, you cannot see Europe. I mean, in Portugal, there is signal coverage for GUI 16, but the European satellite is the Meteosat. Meteosat also use the same protocol and everything, but some stuff is encrypted. But everything I'm talking here, you can use for receiving Meteosat as well. So GUIS is a geostationary operating environment satellite. Being geostationary, you can just point your dish and it just works. You don't need to track the satellite. And here on the left side, there is antenna Luigi, which is one of my friends use it to receive, which is a repurposed Wi-Fi antenna. And the right side, there is my setup, my first setup at least, which is a C-band satellite dish, which is ridiculous common in Brazil. You can buy it really cheap in Brazil because people still use this here. And I just make a modification for receiving in GUIS band with GUIS satellite, which is 1.6 gigahertz. The CAN that's attached there is a Neston CAN. I think you have Neston in Portugal, which is a cereal from Nestlé. It has the right size needed to receive GUIS. Like Pringles cans has the exact size to receive Wi-Fi, and Neston cans has for receiving GUIS. It's funny because I think there is a conspiracy that manufacturer of cans makes cans sized in the right format and shape for radio frequency studies. But nowadays, if you want, I will recommend the Nuelec GUIS kit. I can't stress enough, they are really amazing with the community. They send me one for free. Okay, they are not paying me for that. I'm just saying because their kit is really good. I made a review, so you can see in the left side there is a link to my YouTube channel. If you don't speak Portuguese, there is English closed captions. I translated everything to English closed captions, so it's not auto-generated. I put in English there. It's a really amazing kit. They have been supporting the GUIS community for a long time. They made amplifiers, filters, and everything. And now they made like a complete kit that you have the antenna, you have cables, you have SDR, you have filters. So basically, the only thing you need is a place to fix the antenna, and that's it. You have everything. And my software that I did, which is open source, already supports everything. So you can just like turn everything on and it should work. And Nuelec, thanks enough if anyone from Nuelec is watching. Really thanks for helping the community and everything, and also for sending me that for testing. Okay. And I mean, you can build your setup, but it's probably better to, if you want to start, just get a kit. If you are in the US, they have in Amazon. I think Amazon UK also has it, so I'm not sure how easy it is to get to Europe, but their kit is pretty available. You can also talk to them; they will figure out how to get one. Okay, it's this dish has about 19 centimeters diameter. It's not very small, but it's the smallest you can get for GUIS 16 and Meteosat and things like that. So this is the satellite spectrum from GUIS 16. There are several signals. This is from HackerRef because the HackerRef is the only SDR and the Lime SDR which can see the whole spectrum. Then you can see there is a lot of signals. This spans from 1,680 megahertz to 1,696 megahertz. There are several signals, but we are interested in only one, which is a low bandwidth signal, which is the A-rich. I'm not sure how to talk that in English. It's HRIT, which is the signal on the right side. The signal on the left is the telemetry. We usually short as TLM. You can also decode it. It's not hard to decode, but there's not much information there. But A-rich has images, which is pretty interesting. It's pretty easy to decode. I mean, I made like a whole series about that. There is a written document about how to decode, not from the 16, but from the 13. The 16 is like a bit different. It's bit wide bandwidth. It sends more data, but the overall concept is the same. And this is the set helper app, which is like the fourth iteration of my Open Satellite project. It's made in Golang and it's open source. There is a GitHub project you can check the source code. This software is complete. I mean, you just plug the dongle and your USB, put everything, and you start getting images like that. Okay, there's several configurations that you can do to change images, but basically this is what you get. So if you see, you can like see a tip of the Africa and the right side, but sadly Europe you can't see in the GUI 16. Still, if you are in Portugal or Spain, you can receive it. It's probably be very close to the horizon, so depends on where you live, but it's possible to receive its own coverage. But if you can't receive like the GUI 16, you can also receive the Meteosat. The encrypted stuff, of course, you can receive, but there are some other images that come. Me and a friend added support for Meteosat. It's very experimental because I can't test daily, but feel free to try and let me know if you have any issues about that. Then there are several images. This is the thermal image. This is a false quarter one. This shows the thermal, so it has a thermal scale in the bottom. Yeah, this is the proof that Earth is flat. This is flat, you see? I'm receiving flat images from the satellite, so Earth is flat. Just kidding. The software do the reprojection of the images automatically, but you receive as spheres. So if you don't believe it, receive it by yourself. And there's several ways. For example, if you want to decode it yourself, because I mean, it's fun to get a software and start receiving images, but at least for me, I find fun to actually understand what's happening under the hood. So what's the best way to know than make it yourself? I mean, that's possible. That's not unfeasible. I did, and you can probably do that. So when I did, I was writing every step I did because it was really hard at the time. There are several people that helped me. There will be credits in the next section for them because it was like there was several people that helped me with that. So I just compiled everything in I call it a book, which is the GOIS Satellite Hunt, which is from GOIS 13, but you can also use for GOIS 16, Meteosat, and everything. And it has everything from hardware to software. And if you don't want to build the hardware yourself, you don't want like to start the hardware, and I mean it's not for everyone to set up a hardware to receive GOIS. You can still try. So what I did is I recorded several data from the ADC, so you can start from the software side as you had the hardware. So you don't need your hardware. You can just download a file, which is the recording of the SDR, and then you can just start from there and make everything you want. Okay, and there's GNU Satellite Hunt. There is the link over there. You can use GNU Radio for that. I mean, the GNU Satellite Hunt, there is a lot of mentions from GNU Radio, which helps a lot of software-defined radio. You don't need to code anything. You can just put blocks and then start decoding. The image you see in the middle is GNU Radio. Okay, is the GUI starting signal, and everything here is done in GNU Radio. So you can even do GUIs for showing everything that's happening. So it's really nice to have everything like that. Yeah, I'm just removing the distortion. It's pretty much like a GoPro or things like that, because a geostationary satellite can see like a third of the planet's surface. Okay, so basically you need like 3 satellites to see the whole surface. And so since you see 1/3, what is it? It's the whole circle of the Earth is visible in the frame. That's the maximum you can see with a satellite. So what I'm doing is just reprojecting, because it's easier to visualize in a map fashion than in the circles fashion. So this is the GUI satellite hunt. There are several details here. You can also talk to me if you want about it. I highly recommend playing with it because it's really fun. Yeah, GNU Radio takes some time to get it started. I did this tutorial. I'm still doing, actually, called Set for Noobs, which has like GNU Radio tutorials for decoding stuff. So far, the only thing that it has, it's a FM radio decoder. It's a full tutorial, but it's only FM the radio decoder, which is pretty decent. You can hear radio in your sound card using GNU Radio. It's good to start learning. There is any legal limits? No, there is no for the, at least in Brazil. I can't talk for Portugal, but I think Portugal or Spain. But I think Europe is pretty much like Brazil in that sense. So I will talk for Brazil. So if you want to make sure, just check that. But in Brazil, receiving is not illegal. You don't require any special license to receive anything. Breaking encryption is illegal. Okay, so if you receive an encrypted radio frequency stuff and it's encrypted and you break it, it's illegal. But if it's plain text, it's not illegal. They can't do anything. So even the radios that receive it is receiver only. For example, the RTR SDR, it only receives. It can't transmit. This doesn't get regulated by Anatel, which is the same as FCC from the United States, or I think is CE in Europe. You don't need to regulate that because it's receiving only. So you don't have like any problems receiving. You only have problems breaking encryption, and even breaking encryption, there is some caveats that you can explore. But then it's better to have an attorney or anything, so he can a lawyer that can check that for you. But there's some caveats that allows even encryption to be broken. So also, I have recordings for everything. If you want the recording for a specific satellite, I can see if I can find it. Because if it's a recording, you don't need to care at all. It's just your computer. You do everything by software. So I need to reinforce the great thanks to Nuelec because they support a lot. Nuelec and Lime Micro is the companies that supported me a lot in this project. I couldn't say it was possible without them. The Nyxt 600, the Andrew Beck is from Lime Micro, so also him, because I just put him especially here because I have direct contact with him and Twitter. And I mean, they launched the Lime SDR Micro, the LimeNet Micro. I just said, "Oh man, this is amazing. Can I get one?" And he said, "Okay, sure," and send me one. And it's customized. It has my name on it. So I mean, these companies make a difference for the community, you know. So I can't stress enough. They really help. So every time you see a post from Lime Micro, Nuelec, give them a share, a like, because they're really supportive of it. There is also User Setcon with Joe. Joe is one of my mentors for that. We were talking IRC. He helped me a lot in GUI's satellite reverse engineer because he already did. He had a paid software, so he helped me a lot. So I can, it wasn't possible without him. There's also Dev Nulling, which in ERC was my beat, I think. He also helped me a lot. He still helps me on Twitter and see everything. He sold me a filter so I could use. It was at the time it was really hard to find filters that worked with GUI's frequency. Nowadays it's easier. There's also TNT, which helped. It helps me more recently with FPGA stuff, but at that time he helped a lot in RC for RF stuff and satellite stuff, and several other people, also Macabeus and Worms for the GamConf. It's a pleasure to be here talking about that. And there are several other people, Luigi, and I really bad at names. That's why I hate to do like a section to give thanks to, because I'm really bad to remember names. So if your name is not here, I'm sorry. Please tell me, because I can put there here to next presentation or anything like that. That's how people got. Yeah, exactly. People got pre-satellite TV in the old days like that because there was no encryption, so you can just get it and that's it. So that's it. Any questions? While I read questions, here is the links. I do live streams at Twitch. Nowadays, they are also streaming through YouTube. There is my website, which is lucasteske.dev. You can find links for all my social networks there. GUI Satellite Hunt is also there. You can go to, there is a satellite project section. You can find everything there. There is also my YouTube channel, which has the Nuelec review and several other stuff. There is also the Telegram group for hardware hacking. So if you're Portuguese speaker or not, I mean, the group is Brazilian, but we talk in English as well. There's no problem. And that's it. Any questions?
Hey, Tess.
Hey.
I think you answered most of the questions. We are right on time for Castillo's talk, but if you can just hang around in the chat or people join.
Yeah, sure. I will be in the chat. So
but thanks a lot. The talk was amazing. It's so much content that you'll never find anywhere, I think.
Yeah. And I also had to shorten because it's not much time to talk about it. It's a lot of stuff. So
no, but I think it's nice. You made very nice overviews and also some dives. It was a great talk. Thanks. And
yeah,
well, we'll ask now for Castillo then, if you can help me, Tom, make the change or Bruno. Thanks, Tess,
sure.
again.
See you guys.
And now, hi, Castillo.
Hey there.
Your mic is a bit weird. If you can, maybe, I don't know.
Is it still weird because I'm on my regular?
After you.
Okay, just a second.
Okay. I don't know if Task is still here, but someone sent a question in the chat. If you want to, I don't know if you caught it.
Is it better now?
Hi. Say again. Sorry. Now it's better.
Better now?
Yeah.
Okay, great. I have no idea why this happens. I think like if I spend some time on a call, it just switches to my headphone microphone, which is really bad. So I'm not sure what's going on. But anyway, so I think I can start the talk, right?
Yeah, you can share your screen. I'm gonna leave and then I'll come back later to see if you have any questions.
Yeah, sure.
Thanks.
Just a second here, and then so. Yeah. So can everyone see it? Okay, I'm going to take that as a yes. So just reminding everyone that I won't be able to see the chat while I'm sharing the presentation. So the title of this talk is Weird Machines Exploiting Turing-Completeness. And I'm going to take I'm going to take my time here to explain what a weird machine is, because the concept is not very trivial. So introducing myself for people who don't know me, my name is Pedro Castilho. I've been coding since 2009, so it's been like 13 years now. I'm currently the CTO at Kombuka. We're a fintech that we're like doing a joint account for 2022. Let's say you can like control your finances together with your family or your friends or anybody who pays stuff together with you, or like if Splitwise actually allowed you to make payments and and organize your finances. But other than that, I'm really obsessed with the theory of computation. And that's what led me into the rabbit hole I'm going to talk about in this talk. So I think like the easiest way to actually talk about what we mean when we talk about a weird machine is understanding what's going on in this print. So if you've ever used WhatsApp, you've probably seen some weird stuff like this message where if you touch the black point, then the app actually hangs and sometimes crashes, or some other stuff like messages that simply seeing them inside WhatsApp will crash your app and sometimes will actually throw it into a crash loop, so you actually need to reinstall it. And that's really weird, right? Because this is supposedly just text, right? This at least should be just text. And how can something that is just text cause your phone to crash or something like that? So there are some messages like this, and they look weird, right? But there isn't really anything here. It's supposedly just text, and how can that make something really happen inside your app? So we actually need to answer a thing. So what is text, really? When we talk about text inside a program, what really is text? Is there really just text? And how does that text get on your screen anyway? Because if we want to answer what's going on with those messages inside WhatsApp, we need to understand this process, because the way that actually works is exploiting this process of how the text actually gets on your screen. So it's very easy when you're using a computer to think like everything is just magical. Everything is it just works, you know. You click on stuff on the screen, and like we have these metaphors, right, which we use to understand computers. And these metaphors are so powerful that sometimes we can forget they are metaphors at all. Like when you click on a button on the screen, you aren't really touching a button. You aren't really pressing anything. You're just pressing a button, and it's somehow connected to what you see on the screen, but it's really a big illusion. Like, you're not pressing a button that does anything. There's like a process being triggered by the fact that you pressed a button while your screen was showing a cursor within a certain area and whatever. So everything you do in a computer is behind like this tower of abstraction that really means that there's a lot going on behind anything that happens. And if we want to understand what a weird machine is, it's like we can hide machines in this process. We can hide little computers in the processes that happen behind like everyday things you do. So what's going on when WhatsApp actually renders text? You have this text data, which gets sent to WhatsApp, and that goes over the network, and eventually the app gets a message with a payload containing a UDF-8 binary, and then this gets sent to renderer code, which will actually use your operating system's text rendering facilities to actually eventually generate instructions which will go to the GPU to update the frame buffer that represents the screen with the data for those characters to show up. So there's a lot that can happen here, and there's a lot of abstraction going on. So we have this idea, this metaphor that like you're just getting a message and okay, right, it shows up. But there's really a lot going on down here. And there's actually some parallels to some other stuff that you might have been doing on your computer. So what do we have here? We have like a binary, some binary data that gets read by some code, and that code, based on that binary data, will send some instructions somewhere for them to be executed. And it's easy to forget this. So like, it doesn't matter how declarative something is. In the end, everything inside a computer is imperative. Like the text only will show on the screen if there are imperative instructions going into your GPU and to tell it to update the frame buffer that is like backing with the pixels that show on the screen. And that actually has a really big parallel with something else, with how code gets interpreted, specifically scripts, interpreted code. Python is not really interpreted, it gets compiled to bytecode, but anyway, what you have is some data, initially a UDF-8 binary, then some binary bytecode, which gets processed by interpreter code, which sends instructions to the CPU. So this parallel here is really interesting, right? So you have like a renderer and an interpreter, and they're both sending instructions somewhere. They're both causing side effects. They're both causing things to happen. And what's really the difference here? Well, the difference is that you don't expect WhatsApp to do stuff, to like cause things that you experience as side effects, such as changing the state of stuff in your operating system, or I don't know, like causing something outside of like text showing up in your screen to happen. But there's really nothing that stops that from happening other than the fact that WhatsApp doesn't want to do that. So WhatsApp could really just implement a feature where like if someone sends you Python code, it actually executes that Python code in an interpreter inside the app, and then it sends you the output as a message. They could do that. So really the only difference between what's going on with like WhatsApp and a Python interpreter is trust. You are trusting that WhatsApp only wants to be a messaging app. It only wants to get like some UDF-8 data and send you and show you that as a message. And that's okay. I mean, all you want, WhatsApp has no reason really to do something different than that, because if they did, you wouldn't trust it anymore and you wouldn't use that app anymore. So what's going on here? Why does something happen, something you don't expect should happen when you just click a piece of text, which is something that really shouldn't do anything? Well, this opens up a bigger question, which we could phrase it as, what do your files do when you're not paying attention? Like when you open a file, what's really happening under there? What could happen under there? And what's going to happen is that a lot of times we will have Turing-Completeness going on in systems where we don't expect Turing-Completeness to exist. So being very informal and not going into a lot of detail, Turing-Completeness is the ability of a system to simulate a computer. So if you have a system that can actually simulate a computer inside itself, that system is Turing-complete. And that means it has a lot of consequences. But the main one is that like you have a language. It can be a very strange language, but you have a system of instructions that go on there and that somehow manipulates some notion of state according to rules. So, like I said, you might have some very weird language. You might have some very weird ways of having input and output in that system, but The idea here is that the system will be able to simulate a computer if you define input in an appropriate way, in a way that is consistent and can be read by the system you are using as a computer. And you will have some definition of how output works so that you can interpret the outputs of that system as the output of your computer. So the only practical differences here are really not just trust. It's also the fact that the renderer code is not meant to be Turing complete. It's not meant to be able to do anything a computer is able to do. When you run a Python script, you expect it to be able to do anything a computer is able to do. You expect it to be able to run arbitrary computations. But the renderer code is not meant to do that. The only thing the renderer code is meant to do is making text show up on your device. But how do you guarantee that? And the answer most of the time is you don't. Which means that if you have a format that is complex enough, your renderer or your interpreter of any kind or your file reading program can actually have some effects you don't expect. And that's how a weird machine usually will be built. So how hard really is it for a system to become accidentally Turing complete? Like you're actually building your system and you have no idea really like if it's going to be Turing complete or not. You just wanted to do something simple, but it ends up being Turing complete. Well, a good example here is Conway's Game of Life. Some people might have actually heard it or played around with it, but the idea is that Conway's Game of Life is this game, like a quote-unquote game, with very simple rules that can generate some very complex behavior. And the idea here, like if you look at this, like with the way these cells are updating, is that you only have 4 rules that determine everything that happens on this board. And the 4 rules are based on like each cell, each little pixel here can only see its 8 neighbors. And at each moment, the next state of a cell is decided on based on its 8 neighbors. So the black cells here are alive and the white cells are in the dead state. So the idea is that if you have a cell that has less than 2 neighbors, so it has 1 or 0 neighbors, then it will die. That's rule 1. Rule 2 is if a cell has exactly 2 or 3 neighbors, if a cell has if a cell has exactly 2 or 3 neighbors and is alive, it will stay alive. If a cell has more than 3 neighbors and is alive, then it dies. And if a cell is alive and it has exactly 3 neighbors, then if a cell is dead, sorry, and it has exactly 3 neighbors, then it becomes alive. These rules, they seem pretty arbitrary, right? But
your mic started the noise again. Just so you know.
Okay, just a second here. So is it working better now or same thing?
It's the same.
Okay, I think I might actually have. So the thing here is, like, I know Bluetooth phones are prone to noise, but I'm not actually using the Bluetooth phone. At least I shouldn't be. But I think for some reason, Firefox is actually switching to my Bluetooth phone, which is kind of weird. So I think I might like try to leave here and actually join in a different browser, so we try to avoid this issue.
Just waiting for Castillo. I'm gonna say something to break the silence.
Okay, so I'm back, and I hope it's better now. So can everyone confirm me it's okay now?
Yes, yes, you can hear you very
great.
nicely. Thanks.
Yeah, okay. So I'm going to share my presentation here again. So just a second, and sorry for the technical issues, guys. So just a second here, because I'm going to have to do this a bit different now. But okay. Okay, just a second. I'm going to have to actually reopen this again.
Hi.
Okay, so it should be okay now. Just one more second so I can actually open the presentation. So okay, so here we go. Sorry about that, folks. Hope everyone can see my screen now. So as I was saying, we have Conway's Game of Life, which has these really simple rules, right? And the fun thing here is that these rules are actually Turing complete. So this is actually a CPU built in Conway's Game of Life. And of course, this works nothing like a real CPU. So you see these strings here that look like cables or something like that. Those aren't really cables. Those are strings of little gliders, which are these tiny structures here, which we use to transfer data from one place to another. So even though this is completely different from a real life CPU, it will actually work the same because it's Turing complete, because it can simulate the same thing. You just need to think about input and output in different ways. And the thing is, Conway's Game of Life was not made to be Turing complete. But there is nothing special about RAM memory. There's nothing special about characters on a screen. If you can consistently interpret something and you can consistently manipulate it, you can use it to encode data. And if you have any system that has choice or rewriting mechanisms, like if you can choose based on the state of something what the next state should be, or you can rewrite parts of some state, like based on what that part of the state is, you can say what it should be in the future, then it's very likely you actually do have a Turing complete system there. And what this means is that very simple systems are actually Turing complete, and very simple systems like that can actually show up in many unexpected places. So like when I say rewriting, you can actually implement a Turing machine inside sed. So you can build a script in sed that's like it's only text replacement. And if you provide it an input encoded in the way it expects, it will actually behave as a Turing machine. So it actually reads like from standard input and it writes the output to std out. And that's just sed. It's Turing complete. So when we ask how hard it is for a system to become accidentally Turing complete, it turns out it's pretty damn easy. It's actually harder to make a system not be Turing complete. You need to be pretty careful in what operations you allow a system to do. But what does that have to do with what we're talking about? So what about our text renderer, the text renderer we were talking about when we started talking about this? So let's say you have a text renderer written in like any mainstream programming language, and most mainstream programming languages actually will use at least some functions from libc to implement some of their functionality, because libc is very mature and it implements a lot of common functionality and it abstracts away a lot of, and you have a libc for nearly any operating system, and it will abstract away a lot of operating system calls. So it's very useful to be able to use libc. And you have this thing called a return into libc attack, which is a case where an attacker will use a buffer overflow or other errors in your code to actually make your code call libc functions in some predetermined way. Sometimes they won't even need to use an exploit or anything. They can just build an input to your program so that it calls libc functions in some way. And this is important because libc has functions that can be used to implement a Turing-complete system. So if you have a program where your attacker can craft input, like they can make input that is specifically made in order to force your program to call functions in libc in a way that they actually manipulate the state of a Turing machine, like they can actually make your program compute things for them. They can actually turn your program into an interpreter. And that's what a weird machine is. A weird machine is pretty much an interpreter that is being made out of a program that is not supposed to be an interpreter. And returning to libc attacks are one way of doing that, but there are many other ways of actually making it happen, and I'm going to actually give some real-life examples of this. So when I talk about all this stuff about Turing machines and how you need to be careful that you're not making your system Turing complete by accident, because if you do, it's going to be really hard to avoid some kinds of attacks. That actually, it can seem like, oh, that's just a lot of academic stuff. It's sort of like, oh, some ivory tower mumbo jumbo. But that's not really true. This is actually something that has been used in the real world to attack real systems. And attacks using this can be really nasty and really hard to deal with, exactly because they're using your program just in the way your program was intended to work. So even if we trust the intent of the code, like when we look at WhatsApp, we know that like WhatsApp is meant to be a messenger. We know the devs of WhatsApp don't want WhatsApp to be able to do bad things to your computer. But if they leave corner cases in there, those corner cases might be exploited just doing things that the program is expected to handle. So that's what a weird machine is. A weird machine is a situation where we have a system that takes some kind of input, and we can craft input to actually make that system behave in ways that we want it to behave and that are against the will of some person using that system. And there are a lot of cases of this. You don't really actually need Turing completeness for this every time. But if you have Turing completeness, the attacks can be very much worse and very hard to deal with. So what's going on in our WhatsApp example after all? So you have this message with a black point, right? And you look at it and it seems like, it seems pretty inoffensive. Like it's just a black point and a message. But if you take this message, it's actually Unicode data. And if we get this Unicode data and we throw it into an HTML converter, which is going to make the Unicode characters visible, what is actually being sent to you is this. And you see these characters that are like LRM, RLM, etc., etc., etc. So what are these characters? Unicode has a feature where you can throw in an invisible character that says to Unicode, okay, from here on, the text direction is changing. So if you have like mixed Latin and Hebrew text, for instance, or mixed Latin and Arabic text, the Latin text, it wants to go from right to left, and the Arabic text, it wants to go from left to right, sorry, and the Arabic text, it wants to go from right to left. So the way you tell the text renderer to change the direction it renders the text in is that you send in this character, RLM or LRM, which are a right-left marker and left-right marker, to say, okay, from here on, this text is going to be either right to left, or like Arabic, or left to right, like Latin text. And when you click text in WhatsApp, you're actually going to select it. It's how it works by default. So for you to be able to select text, the renderer actually needs to know which direction the text is going in, so it knows, like, should I select to the right or to the left? So it's pretty simple what's going on here. It's just that the text renderer is looking, okay, this person wants to select text, but I have this bunch of left-right markers. So now I actually need to process all of them to know which direction this text is going to go in and which direction I should select in. And since you have a lot of them, this is actually exploiting a weakness in the text renderer, because the handling of left to right and right to left text is actually pretty complex in Unicode. So they're using the fact that they know that that is pretty complex to make your phone deal with a pretty complex operation, which is going to take a lot of time and a lot of memory, and will eventually make your app crash. So this is actually pretty innocuous, all things considered. The worst it can do is like make your app hang or crash, which isn't even close to the worst things that can happen when you have a program interpreting some input you don't expect. So what kinds of other payloads could we craft? What kinds of payloads could we craft, like if we really have a Turing-complete situation, if we really have the ability to run pretty much arbitrary code based on what's going on inside the program? So there's this XKCD that I think it represents pretty well, actually, how tech stacks work. So you need to assume that pretty much everything is compromised, that pretty much everything has some kind of vulnerability, and only the fact that you have control over input and output, and you can decide how to handle input and output, is what is stopping really your code from being exploited. So how do you actually craft a weird machine payload? You need to reverse engineer the program. You need to figure out a set of functions that is Turing complete, or that can do something that is against the will of the user. And then you implement a payload that acts as a program for that Turing complete machine. And that way you can turn anything into a scripting engine, as long as it exposes some set of operations that are triggered by input that turn out to be Turing complete. But you can only do things the program is allowed to do, right? So if you have WhatsApp, the worst things that could happen are, like, you could render some text, you could make it hang, but you couldn't really, like, if you don't have like the message sending function exposed in response to some input, you can't really force the user to send a message or anything like that. Well, yeah, but that's where the fact that everything has very likely exploits that can be used comes into play. Because you have stuff like rowhammer, where you can write memory you have no permission to write based on hardware bugs. So if you do a lot of writes really fast, you can usually corrupt some memory in different locations. So, and most code will eventually write memory. Like when you modify a variable, that's probably going to be a memory write. So it's very rare that you get access to some code that runs in response to input that can't write memory, for instance. You have good old buffer overflows, which are the base of most exploits, really, where you can actually run code outside of the boundaries of the code that really should run. You can actually change variables to make you access things that you shouldn't be able to access. And if you have that together with some Turing-Completeness, you can do some really bad stuff. We're going to talk about a real-world example about that soon enough. And like the WhatsApp example, you can do a denial of service, you can make an application crash, and that's no big deal if it's WhatsApp. You know, it's going to be a bit annoying. You're not going to be able to send messages for a few minutes, or maybe you'll have to reinstall it. But it's not the end of the world. But what if this is critical software? What if this is something running, let's say, in a financial institution, or this is something running in a hospital, or this is something running anywhere that you, like in a factory? And the halting problem means that we actually can't detect these reliably if you actually have Turing-complete operations in response to input. So detecting input that would trigger denial of service that would trigger a crash is actually not possible for the general case. If you have very specific cases, okay, you can do it, but in the general case, you would need to solve the halting problem, and that is proved to be impossible. So this is just a way in which you can see like these kinds of attacks, they can be very nasty. You also have side channel attacks where you can actually read the contents of memory you're not allowed to without doing any memory reads. So there's a lot of stuff that can happen, and I'm not a security expert. I don't know like a full list of what could happen here, but if someone has control of operations inside your program and they actually manage to build a payload that acts as a script inside your program, they could do a lot of stuff. And they would mostly need other vulnerabilities, but those are everywhere. The entire tech stack is compromised. That's just a fact. So now that we have a bit of an idea of what weird machines are, how they behave, and what they can make happen, I want to talk a little bit about some actual weird machines in the real world. And there's been a high-profile example of a weird machine actually being used to exploit actual machines in the wild, which is the NSO zero-click exploit, which was discovered, I think, in 2021. And NSO is an Israeli company that they sell spyware to governments. That's really their business. So they sell tools that allow governments to spy on people's phones and to get data from that. And they actually developed this very ingenious exploit that it's very impressive because it's actually a zero-click exploit. You don't need to do anything like to activate it. Most exploits, you need to click a URL that will actually send you some payload that initiates the exploit. But in this case, you don't need to do anything. It's just a message that they send you, and you receive it, and your iPhone is compromised. So how does that work? So this exploit is known as forced entry. And it's a way to infect iPhones with spyware by simply sending an image via iMessage. And the user doesn't even have to open the image. In fact, the image, it's broken. It doesn't show anything. It just shows like a message with no content. And the moment you receive that message, you're bombed. They've already gotten a malware payload into your iPhone, and there's nothing you can do about it. And it's been fixed in the latest versions of iPhone, of iOS, sorry. But it's really scary because this is a case we know of, right? But there could be a lot more of these in the wild, and we don't know if we're safe or not. So how can this work? So there's this article from Google Project Zero where they actually really dissected it. And most of what I'm going to show right now is based on this article. And I encourage everyone to go read it later. It's really good, and it doesn't really require a lot of domain-specific knowledge. If you understand a bit about computer memory, you can mostly follow what's going on. But okay, so what's the idea here? So this exploit was actually discovered by examining the phone of a Saudi activist, and they figured out what was going on with it. So what's the idea here? Whenever you get sent a file in iMessage with the .gif extension, and I'm going to say GIF, I will fight you, that is the right way to pronounce it. It's going to call this function. So the syntax here can be a bit weird if you don't know Objective-C, but this is essentially just this is the same as doing like the class name dot method, and those are the arguments. So it's calling this function that copies a GIF from a path to another path. So what they're doing is like, you're getting this GIF. It's in some folder. They're going to copy it to your images folder. But the issue here is that the way this function works, and I don't know why it was implemented this way, maybe just laziness, maybe they just wanted to reuse code. But what it actually does is it opens the GIF file and it runs the renderer to actually render it into a new GIF file. And that's where the issue starts. Because like I said, if you have a text renderer, it needs to run some instructions, some side effects based on the content of the text. And here it's the same thing. The renderer needs to run some instructions based on the content of the GIF. But notice that I said when iMessage gets a file with the GIF extension, it doesn't mean that the content of something that has a GIF extension is necessarily a GIF. So what happens here? Part of the issue here is that Core Graphics, which is like iOS's framework for rendering anything, it doesn't really care about the extension of files. It uses the magic number from the file data. And the data of that GIF was actually a PDF that contained a JPEG-2 image. So what the hell is a JPEG-2 image? That's probably something most people really haven't seen. So the idea here is that JPEG-2 is a very old compression. It is a very old image compression format that is mostly made for scans of black and white images. And the idea of how it works is that it will look, so you usually have like these scans and they will be mostly text, right? And text is going to be repetitions of just the same letters. So what JPEG-2 does is it searches for similar areas in an image. And it says, oh, okay, this is showing up a lot in this image. This is probably a letter. So what it will do is for each area where this pattern is repeated, like where it's very similar to one another, instead of storing the pattern, what it will do is storing a single instance of the pattern, and then for each time it appears, it stores the difference, and then it can apply Boolean operations on the original and the difference in order to reconstruct the original pattern. And that saves a lot of space. It was very popular for scanning machines in the early 90s. It's not really used anymore, but because it was so popular, Core Graphics actually has a renderer for it. And the idea here is that the decoder that Apple uses is open source, and it contained the buffer overflow vulnerability. So like I said, usually you will need to have some other vulnerability in order to exploit the weird machine. But in this case, there was this buffer overflow, and they could use this to set the end of the bitmap to a huge address. And it actually allowed them to modify the bitmap data itself in order to set it up in a very specific way. So now you have a decoder that can write anywhere. But that's not really useful. Like if you have a buffer overflow exploit in JavaScript, for example, okay, you would now have like this big array in JavaScript, and you can write into it using JavaScript. But here you're inside an image decoder. So how are you going to write? How are you going to actually read that memory in order to be able to figure out what's in it and what you need to do to actually get the phone to actually download your malware payload and actually run it? So the idea here, and it's really, really clever, is that they make a weird machine inside the decoder. And the key here is what I said, like the JPEG-2 image format, it stores these segments, they call it, that are like repeated pieces of the image that have very small difference to other parts of the image. And they store the sequence of operations, of Boolean operations you need to do on that data in order to compute what you should write into the memory in order to recover the final image. So you have Boolean operations, and you have this very carefully manufactured image. It's not really an image, it's actually a script, which uses these Boolean operations to actually build a weird machine and make it run instructions inside your computer while the phone actually thinks it's just decoding an image. It's just doing what it should do in order to decode an image. But what it's really doing is running a script. And what's the issue here? If you have and XOR, and you definitely have both of those in order to reconstruct a JPEG-2 image, you have NAND. And this is how you build a NAND gate from NAND and XOR gates. And if you have NAND, as anyone who has studied computer architecture knows, you have a full computer. So what they actually did was build a computer into this image payload that included like registers. It had a 20-bit adder. It was really impressive, and they actually used this virtual machine in order to embed a scripting, effectively what was a scripting language, into the image data, and do arbitrary code execution using the image decoder. And the image decoder, it actually ran with some degree of trust from the operating system. So it was able to access some areas of the operating, or some areas that were reserved by the operating system. So it would use the Objective-C dynamic code execution facilities to delete the fake GIF file that started the process. And then it would use some more vulnerabilities, which were only accessible to code with elevated privileges, to start running some code in a different process that had even more privileges using inter-process communication, which fully allowed it to escape the app sandbox. And then it would download a malware payload and make the operating system run it. So now you're pawned, and you didn't do anything. You just received a message containing a fake GIF, and that fake GIF turned your decoder into an interpreter. This turned the image decoder into an interpreter and made that interpreter pawn your own phone. So you don't need to do anything. You have no way to defend against it. And once again, this is everywhere. Everything is compromised. Everything has vulnerabilities that if you have a Turing-complete set of instructions inside any kind of program that can be triggered by input, eventually someone will find a way to build a computer inside your program and use that to take over the computer where it is running. So that is an actual example of a weird machine in the wild, but there are many places where weird machines can be. And some examples are in ELF metadata. So I'm going to cite some papers here that are quite interesting. Most of them are explaining some proof of concept in order to build weird machines in different kinds of file formats that really show how everywhere you're really able to build Turing-complete systems and actually force computers to run code they have no idea they are running. So in this case, like the ELF file is the executable file which most Linux distributions use. And the idea here is that the ELF files, they have these symbol tables, which are instructions for the dynamic linker. So right, when you say you have a dynamically linked library, then the ELF file actually has some instructions to tell the dynamic linker how to get that file and actually load it into memory. And what they did here is that they figured out that there are a few instructions that the dynamic linker runs, which are actually equivalent to brainfuck if you set them up the right way, and actually build a compiler that makes like an ELF file that actually runs a brainfuck program. Another case of a weird machine is page faults. So this one is actually, it could be used for some pretty nasty exploits, because how do anti-malware programs detect malware? They usually will look for certain sequences of instructions, or they will look for patterns they know that could represent malware. But in this case, when you have page faults, you're actually computing without any kind of instruction. What you're really doing is just setting up memory tables that specify how the operating system should handle page faults. And they just make a sequence of page faults happen, and they prepare the tables in the memory in such a way that you can build what we would call a one instruction computer, which is like it just keeps repeating one instruction over and over. But if the data is built the proper way, this is actually it can actually execute any program. And finally, this last example, I'm actually not really sure that it's Turing complete. I suspect it is, because it has fonts have a very powerful replacement system. And so there is this very interesting program that was published in Page Fault magazine in 2019, which is Spooky Fizzbuzz, which is essentially a Python program that all it does is open a graphical window and output numbers from 1 to infinity. It just keeps writing numbers, right? So the spooky part is that you can actually check the program, and that's all it does. It loads a graphical window. But when you look at the graphical window, it's actually fizzbuzz. Like when it writes 3, it says fizz. When it writes 5, it says buzz. And the program is just outputting numbers. So the way this works is that it actually loads a font in order to show the numbers that it contains ligature instructions. So what are ligature instructions? So there's an example here, like if you write FFI, it actually connects the characters, and a font actually has to have instructions to do that. So it needs to say, oh, if you see this sequence of characters, then you need to replace it by this character or this sequence of characters. And this is very important. Like you have, if you have Arabic scripts where characters need to all connect to each other, some Indian scripts too, the characters need to connect, and you have some pretty complex replacements. Like especially in Arabic, I know you have characters that will be different if they are at the end of a word. So this logic needs to be very powerful. And the idea here is that this file, it specifies some replacement tables that they actually implement a state machine that it figures out every time you write a character if that character is a multiple of 3, a multiple of 5, or a multiple of both 3 and 5, and it actually replaces that character by fizz or buzz or fizzbuzz. And this paper, it actually asks a really cool question, which is, could a font be malicious? Like, we're just making a toy here, we're just playing around. But what if a font would replace one word with another, like in rare occurrences, or if it had logic inside of it to detect medical dosages, or if it had logic in it to detect financial information? So what should we take out from this? First thing is we need to be very careful about opening untrusted data of any kind. It doesn't matter if data seems harmless. If it has a sufficiently complex logic in order to process it and show something to the user, you could be opening yourself up to specially crafted input that would force you to force your program to run some sort of code you don't expect. And even if your data is sandboxed, even if there is no way for those instructions to actually escape the little space you run your app in, you can still get a nasty denial of service. And if your code is actually critical, then that can be really bad, obviously. And when you see how some kind of file format is processed, you should be really suspicious of choices of rewriting of Boolean operations, because all of that can be signs that there is a weird machine lurking inside your code. Always validate file types. This is, so we have the NSO example, right, where they actually send you a GIF and it's not a GIF, and that's really a simple vulnerability, but it's something programmers want to do most of the time, and there's a lot of issues with that. Like iOS usage have some issues with XML, because like iOS uses XML a lot for configuration, and what happened was that different parts of the operating system used different XML parsers, and those parsers they interpreted some constructs differently, and there were some really nasty vulnerabilities because of that. So be really careful about file types and how they are treated. And I think one of the most important things is that every program should have the least power possible in order to execute its function. So really, you shouldn't be giving a program the ability to do powerful operations. Like, once again, the NSO exploit, it could only happen because when you were copying a GIF inside a program, you're really rendering a GIF. So that actually triggered the renderer, and that's where all hell broke loose. And finally, like I said before, language theoretic security, which is this idea that we should consider input for any program really as being like a programming language, and consider it and try to analyze really how much power it has if it is really Turing complete. That isn't an ivory tower issue. It's been used in real life. It's probably being used right now. Like we know that NXO exploit because that was the one Google Project Zero caught. But we don't know how many exploits are out there that no one has understood how they work yet, and it's probably a really big number. And one thing that I would like everyone to take away, if you're going to take away just one thing from this talk, is that only simple formats can ever be safe. If you try to make your file formats really smart, you're probably opening yourself up to security vulnerabilities. It's better to have a simple program with a simple file format that doesn't try to do anything fancy if you can. to having a really complex file format with that, like you need to do a lot of really fancy instructions to reconstruct the data that is in there. So if you really need to have a complex file format, if you're doing something like audio and you need a special encoding, then you should be really, really, really careful about what kinds of operations you're doing. And that's it. Thank you very much. And I'm available for questions now.
Thank you. I was looking to the chat. We had many comments, but I don't think we had a specific question. If anyone's going to throw one now. And the talk was great. It's nice to think that everything you interact, there's almost like a live ecosystem of things making that work.
Yeah. Yeah. It's really fascinating and sort of scary at the same time. Yeah, Microsoft Office is really a bad one about that. It's really a huge offender.
Oh, it's fun. Well, thanks, Dan Castilho. It was a really nice talk. If anyone wants to talk with him, he answers a lot.
Thanks for inviting me. Yeah, I'm on Twitter. My Twitter and my GitHub are on the screen, and I'll be here for a while.
Nice.
Anyway, thanks everyone.
Thanks, Castilho. So I think, Bruno, if you're here, you can join me maybe.
Okay, hello. Okay, hello everybody.
And Bruno, thanks for the invite for doing this, the hosting part. And I'll leave with you now. Thanks. I'll be here if you need.
Okay, so no, I'll be very short because I'm tired as well. For the holidays, a lot of content, mind blow moments, surprise about computer, crazy stuffs. Okay, so I just have a very simple announcement, okay, that the upcoming GambiConf edition will be back to Brazil again. So the next edition will be in São Paulo. I don't know exactly when the conference will be open or the date, the venue, etc. But you have sure that the next edition will be back to Brazil, São Paulo. And if you want to be the update that when it will be open is about the conference papers and so on, please follow us on Twitter and the LinkedIn as well, our social medias. And thank you for.
Thank you. We're going.
Bye bye.
You can finish the recording now, and we're gonna edit it.